잠시 후 2021년 울산 국제 수소 에너지 포럼 수소 모빌리티 세션이 시작될 예정입니다. 로비에 계신 여러분들은 자리에 착석해 주시기 바라겠습니다.
We are about to start the second day, the Ulsan International Hydrogen Energy Forum. Please be seated. Turn off yourself into the silent mode. And please, to keep up with the regulation regarding corona pandemic, please wear the mask all the time.
동시 통역이 제공되오니 통역 수신기를 이용하실 경우 한국어 채널 1번, 영어 채널 2번을 안내해 드리겠습니다. 본 행사는 10시부터 온라인 유튜브 한국어와 영어 두 채널을 통해 동시에 중계될 예정입니다. 10시에 시작하도록 하겠습니다. 아마 유튜브 채널로 전 세계로 중계.
So this will be a live cast or broadcast across the world. So we have still empty seats in the front rows. Please come forward and fill the seats first.
수소경제, 비즈니스, 글로벌 수소경제 대전환의 시작. 2021 울산 국제수소에너지 전시회 및 포럼. 수소경제를 대표하는 기업 100여 개사 참가. 30개사 글로벌 스피커 강연까지 11월 10일부터 12일까지 울산에서 만나보세요.
예, 안녕하세요.
Good morning, everyone. I'm the chair of the H2WORLD, head of Energy Technology Support Department of Ulsan Technopark. I'm the chair of this session, Hydrogen Mobility. First of all, I'd like to thank the presenters and distinguished guests for being with us despite your busy schedule. Also, I'd like to recognize those of you joining us virtually. Before we start, I'd like to walk you through the schedule of the Hydrogen Mobility Session for 2021 Ulsan International Hydrogen Energy Forum. So we'll have a presentations on the applications of diverse applications of hydrogen fuel cell mobility and special sessions and panel discussion. Then now we'll start the presentations. Due to COVID-19, some of presenters couldn't make it here, so they send us video footages ahead of time. So first presenter is Sang Hyun Kim, a senior manager of Fuel Cell Business Unit. And he will talk about advance of hydrogen society and Hyundai Motor Group's vision. Please welcome him with a big round of applause.
있습니다.
Hello, ladies and gentlemen. I'm Kim Sang-hyun from Hyundai Automobile Group. From now on, I'd like to talk about the hydrogen society's coming and our vision relevant to that future. First, let me cover the energy paradigm shift. Actually, I was listening to your conference yesterday. There was some overlapping parts, so I will skip that. So I will briefly mention the carbon neutrality shortly, and then actually, as the society grows up, there's a bigger demand. But to climate change response, we have to reduce the carbon dioxide. So to reduce that, we have made a lot of efforts. And we want to get away from using the fossil fuels. That is the current energy paradigm shift. So let me show the graph. This is IPCC's report announced in August. You can see that to make sure we are increasing temperature rise within 1.5 Celsius degree, we will face the serious consequences. So to achieve the net zero, we are focusing on the renewable energy resources. In many countries, they declare the global carbon neutrality, and they come up with their strategies, visions, and budget. America, EU, and Japan has targeting for 2050, and China targeting for 2060 in this goal. Korea is no exception. We also target the 2050 for carbon neutrality. According to national visions, many industries following, including the automobiles and the other industries, also have a similar declination for carbon neutrality. Hyundai Motor Group is also no exception. We are targeting between 2040 to 2050. Other energy sectors also targeting 2050. For carbon neutrality, many other industries will follow suit, I believe. Let me give you the more details regarding the Hyundai's net zero declination. Recently, in 2021 September, in the Munich AA Mobility, Hyundai declared electrification and hydrogen society establishment. from the part procurement to production to implementation driving. It means that we will implement electrification and the hydrogen technology in full swing. As you can see, we are targeting to implement the electrification into our signature brand Genesis around 2025 and 2035. We also achieved the 100% electrification for European market and also followed by the 2040 for major market electrification. So this is our goal for the carbon neutrality to achieve by 2045. Let me cover the renewable energy. Why is it so much gaining attention? Especially hydrogen is getting popular. Why is that so? Hydrogen energy is part of the renewable energy, but this is a great alternative to reduce the gap between the areas and the seasons. As you can see in the slide, of course, there are many differences in each country. However, if the renewable energy provide oversupply, the oversupply can be stored or transported by using the hydrogen technology as a carrier of that energy. That's why hydrogen has much gained attention recently. If you take a look at this, the long-haul transport between countries, for example, if the South America has an oversupply that can be used, transported to North America, that kind of deal can be achieved in Asia too. So hydrogen transport can be possible cross borders, of course, without any carbon dioxide emissions. So the importance of hydrogen has been bigger and bigger. Therefore, there are many research regarding that. If you take a look at the value chain from the production to storage to utilization, these are three main pillars for hydrogen technology implementation. As you can see, there are many pilot projects going on around the world. And for Korea, we are no exception. 2017, Global Hydrogen Committee was established, including the 17 companies, but now it has grown to 140 companies. Likewise, Korea established a committee with the 15 members. I believe that more and more companies will join us in Korea H2 Business Summit. Let me cover the prospect of the hydrogen industry. With the hydrogen tax introduction, green hydrogen will have a price competitiveness. But between the countries, there are price in hydrogen. As you can see in this graph, in Australia, regarding the green hydrogen, Australia and China, $1.52 per kilowatt, compared to the Japan and Korea will expect $2.5 to $3 per kilowatt. So the price unit will be different for green hydrogen. So because of that, I expect there will be the active export and import business happening. Some country will be the supplier, other country will become the importer of the green hydrogen, such as China, such as Japan and Korea. Especially Korea will have to depend on import of the green hydrogen. So in this case, we have to make sure that some countries will end up being the importer of the green hydrogen technology and green hydrogen. Let me cover the hydrogen utilization in the perspective of the mobility. Norway targeting 25, and other countries target have a different year, but in general, by 2030, many countries are banning the use of the combustion engine. With that enhancement of the regulation, automobile industry try to go for the electrification, focusing on developing electronic vehicle, especially fuel cell will be the good alternative to the long-haul heavy-duty trucks and commercial trucks, trams, and ships, I believe. So let me cover the OEM trend of the hydrogen electronic vehicle. About like 10 years ago, there are more companies actually involved to develop the hydrogen, even though it was never reached the commercialization. Despite the high investment, but because of the low return on investment, many companies give up. But nowadays, there's a new trend coming up because of the new focus on the hydrogen technology. That's why, because we have a more development in hydrogen electronic vehicle, and Daimler, Volvo started the joint venture. Toyota, BMW also have a good example to develop the system jointly. So there is a collaboration between the automobile OEMs in China, Toyota and China, Nimaton also share the R&D. So even fuel system company and the OEM company have a joint collaboration. So let me cover the story of Hyundai in develop of the hydrogen. We have a 25 years of the history to develop the hydrogen technology. In 2013, for the first time, we successfully commercialized the Tucson with the electronic vehicle hydrogen technology. So globally, Nexon has been sold over 10,000 units. In 2020, the commercial truck were also produced for commercialization. One charge, it covers 600 kilowatt. The other vehicle covers 400 kilowatt for one charge of the hydrogen electricity. As I explained before, besides the passenger cars and the commercial cars, we also have the mobility area we want to focus as part of our vision. To secure the hydrogen, electricity can be used as an emissionless energy source. So we want to apply many cases of the hydrogen. As you can see, we believe that we can provide electricity with hydrogen into area where electricity can be very scarce. So besides the vehicle, we can apply hydrogen technology into many different parts of the world. This is our target for a hydrogen economy. I believe that many cases of the hydrogen into shipment and other specialty area will be introduced. I'm sure you will learn a lot from today's conference. Hyundai also start to sell of the fuel cell technology. For our international client, we want to sell our technology so the hydrogen technology can be shared by many. We also participate in the hydrogen wave, a Hyundai group. By 2040, we want to turn the world around toward the hydrogen economy. So this technology can be applied to aviation and many other areas. So the Hyundai vision regarding the hydrogen is that we want to invest 11 trillion won. We want to create 50,000 vehicles, and we also want to create this system worthy of 70,000 units. And our slogan is by 2030, we want to be, this is a turning point. So everything, anywhere, everywhere for hydrogen society. This is our long-term goal. So we easily say that hydrogen economy. So it truly means that we use hydrogen technology as a main energy source without creating any damage to the environment. So they can be used from the supply to storage to utilization. This can be happen only with the collaboration with the many stakeholders such as industries, academics, governments, and many R&D centers. We need to be involved all together to create the future hydrogen society. I believe we play a big part in this effort. As a Hyundai declared,
선도에 나가고자 노력을 하겠습니다.
we will make the effort to lead this way. Thank you.
유익한 내용을 발표해 주신
Thank you, Sang Yeon-kim, for a good presentation. Please give him a big round of applause again. Please understand that we couldn't transmit the video footage in the middle of the presentation. Please understand that. Next, a presenter is Norman Cho, Asia Pacific Account Manager. Will talk about the future of the zero emission marine propulsion. And please understand that he could not make it to Korea due to COVID-19, so he actually joined virtually. Please welcome him with a big round of applause. 안녕하세요, 여러분. 저는 발러드 파워 시스템의 노만초입니다. 저는 아시아 태평양 지역의 비즈니스 개발 업무를 담당하고 있습니다. 이렇게 주요한 탄소 배출 제로에 대해서 그리고 해양 분야에 대해서 제가 발표할 수 있는 기회를 주셔서 감사드리고요. 제가 올해는 직접 참여를 하지 못했습니다.
Participant H2WORLD. So it is unfortunate I was unable to attend, and I hope I can attend next year. So on a global scale, right, the shipping industry really contributes a very significant share of greenhouse gas emissions. So, these numbers are a little bit older. I think they're about 2018, but the trend is still correct. So on an annual basis, the shipping accounts for about 2.2% of the CO2 emissions globally, 15% of NOx, and 13% of NOx for global emissions. So, this is a very significant amount of emissions from just one industry. So in fact, this is an old statistic, but people were saying that global shipping, if you count global shipping as a country, it would be the 6th largest producer of greenhouse gas emissions. And only United States, China, Russia, India, Japan emit more CO2 than the world's shipping. So, from a macro perspective, right, the marine industry is facing a lot of pressure right now to reduce carbon emissions. So governments, port authorities, and even non-government authorities, they're really trying to tighten up emission standards. And there's several proposed regulations. So, IMO, for example, they have pledged cutting emissions by about 50% from the 2008 levels by 2050. And actually recently at COP26, at the United Nations COP26, people are already saying that this is not aggressive enough. And it does not align with the Paris Agreement. So people are asking and really demanding that the industry targets zero emission by 2050. So right now, the IMO, they are planning to revise some of these emissions. So we'll see in the next 1 to 2 years, but it just shows that this industry is really, really going to be under a lot of pressure. And they were saying that even during the pandemic, when there were lockdowns all over the world, shipping emissions was only cut by about 7% in 2020. So it's not aggressive enough to just say, 50%. We're going to have to go much further than that. Another really big driver, and this is actually driving near-term demand for zero-emission marine, is actually Norway. So out in Northern Europe, the Norwegian government, they already have a resolution to have no emissions from some of their cruise ships and some of the ferries in the West Fjords by 2026. This will make the fjords probably the first zero-emission zone in the ocean. And this is a major destination with a lot of large passenger ship traffic. traffic. So, these are types of, pressure from the macro side that's really driving zero emission marine. And what's really interesting is outside of politics, in the commercial space, people want it even faster. So Amazon and IKEA, they recently announced that they will only use zero emission ships by 2040. So at some point very soon, boat owners or boat operators, they will need zero emission vessels. And we think that, fuel cells, fuel cells is going to be the technology that provides that solution. So who is Ballard, right? Ballard's a big name, and our company has changed a lot over the years. So I'll give a very quick introduction. So Ballard, we deliver fuel cell power for a sustainable planet. We work in markets where fuel cells have the strongest value proposition. So that's markets that have heavy payload, high utilization, and long distances. So specifically bus, truck, rail, and marine markets. Our key geographic regions right now is really China, Europe, and United States. These are regions that have very strong decarbonization policies, but we're starting to see that all over the world, right? So we expect to expand our business globally. We're also the leading independent proton exchange membrane fuel cell developer and manufacturer. So we've been in the fuel cell industry for 42 years. So we're one of the oldest pure fuel cell companies. We have over 900 employees across Canada, China, Europe, and United States. And our corporate headquarters and R&D is all in Vancouver, Canada. Our technology has powered about 3,500 fuel cell buses and trucks globally. And we've accumulated about 100 million kilometers of on-road experience. In the emerging applications, so we're seeing a lot of trends towards trains and marine. We right now have 7 train projects in progress and 5 ships in development. We have delivered over 850 megawatts of fuel cell stacks and fuel cell systems. And because we are a vertically integrated manufacturer, we have manufactured over 6.5 million membrane electrode assemblies. So, in our 42-year history, we have made significant investments in this technology. We've invested over 1.5 billion US dollar in PEM technology, which, at a big scale, it's a small amount of money, but to put that investment into one technology is actually, quite a bit of investment that we've made. And we have achieved many advanced technology milestones. So a lot of the vehicles that we see today, utilizing very high power fuel cell stacks, high stack power density, cold start. This is all technology that we've been developing for 42 years. Our IP portfolio now has over 1,400 patent applications. So as I mentioned, we are a vertically integrated supplier. So we offer products all types of at all different levels of integration. So we could supply stacks, we could supply systems. It just depends on what the customer wants to do with our products, and it depends on what type of customer they are. In some cases, we've also developed and supplied megawatt level fuel cells for infrastructure backup and distributed power generation. So, as I mentioned, Ballard, we focus mostly on heavy duty mobility. Okay, so applications that have heavy payload, high utilization, long distances. So, fuel cells really have the compelling value proposition for zero emission heavy duty transportation. We think that, the only near term zero emission transport options is battery electric or fuel cell. But fuel cells are probably the only technology that can directly replace diesel in all applications. So it's not just about zero emission, but for the user experience, we want to make sure that it's almost transparent. They just see it as I'm replacing my diesel vehicle. So just some examples, okay? So for buses, fuel cell vehicles, you can operate any route, anytime, any weather condition. You can match a diesel bus. For trucks, And some of the partners even at this event, you'll know trucks it will give you comparable distance to diesel, and it's much lighter than batteries. So as an estimate for everyone, a fuel cell truck, you could get about 30% more cargo capacity over battery just because it's lighter, over a 300-mile range. For trains, this is very interesting for the market right now. You do not need to electrify your train or your tram. You do not need to invest in the electrical catenary system. So that's a huge amount of savings from an infrastructure perspective. And also for the operator, you could just replace one train at a time. You do not need to replace the entire fleet. So again, it makes it so that adoption is practical and it's not too expensive. Now, for marine, which we'll talk about a bit more in some of our activity there, it really is the true zero emission solution that we feel can meet all types of environments and applications for the marine sector. It's quite different from land mobility, and we have been working with industry experts to develop solutions for that. So again, in all cases, fuel cells, we think of it as the most direct one-to-one replacement to diesel vehicles. So, just at a very high level to give everyone an idea, like to date, we have powered over 1,300 transit buses globally, 2,200 trucks, mostly smaller logistics trucks, but we are working with our partners, Wed-Fri, Mahle, Quantron, and Kenworth, and we're looking at larger trucks right now. 7 train projects in progress right now, with 9 trams in service in China. And we're working with Siemens to develop a new tram. We have projects in the United Kingdom, and now we're working on freight locomotive, which maybe in the future I'll share more information about. And then for marine, again, we have 5 vessels in development, and I'll share a little bit about those projects. So, fuel cells have been very successful for land-based heavy-duty transportation, and now we're looking at fuel cells for vessels, for marine vessels. We think fuel cells will play a key role in helping address greenhouse gas emissions on water and in ports. And some of the key benefits, it's actually very similar for almost all cases. It's all about long range, and especially for a vessel, the range is very important. Hydrogen is much lighter and much higher energy density than a battery. So the fuel cell vessel, you'll have longer runtime, and you can travel a lot further before you need to refuel. Hydrogen vessels, they refuel very quickly, just using gaseous or liquid hydrogen. Fuel cells, you can get very modular and very scalable. So I'll show you our product to give you an idea of why this becomes important on the vessel. And fuel cells, they provide very stable and reliable power. So we've proven that in thousands of vehicles, land vehicles already. They require very low maintenance costs, and very long service life. So, if you combine this with something like renewable hydrogen, then you have really a true zero emission option. So what we did is we designed a fuel cell system specific for the marine environment. It's called the FC Wave, and we designed this with industry requirements, with industry partners. The way it's designed is, on the very bottom, we have all the connection points at the bottom and at the very top. So they fit in an engine room in a vessel. It's designed that you can take the system apart in 2, so you could, handle it easily. You can move it around the ship. And it has 2 giant doors that you can just access for easy maintenance. So again, we thought about what happens on a vessel and how do we make it very, very easy for people to be able to use this inside a vessel where you don't have as much space and accessibility as you do on land. This system will be type approved. We're working with DNV-GL on this, so it will be type approved, and it will become quite simple, I think, for the vessel makers to get their safety certification. And again, with fuel cells, it's really an onboard electrical power generator. So you could use this to power anything. It could be for propulsion or for auxiliary power. So some of the early applications for the zero fuel cell on marine, what we see is coastal and inland ferries and barges. So things that are a little bit closer to land. And this is driven because it's easiest to access hydrogen. Right now, people in especially Northern Europe, they're looking at refueling options that are close to the port. So that's really driven by access to hydrogen and not really because of the technology that we're focusing applications that are close to coast. Progress right now is, there is a lot of progress to make this usable for large ocean-going vessels, but it will require a bit more work, I think, with the industry. We have to understand better about the drive cycle and different hydrogen storage options when you're traveling, 30 days at sea. But fundamentally, the technology is the same. We're not going to redevelop technology. The marine industry does not need to wait for new technology to be developed. It's all about integration. How do we work with the partners to find the solutions to put it onto an ocean-going vessel? So, as a rough idea in terms of use case, most of the projects that at least we're working on right now, they're vessels that are traveling further than 1 hour, but not going to the ocean. So close to coast, but longer than 1 hour. So we designed the system with 5 key things, talking to the industry. There's 5 really important things that the industry wanted out of a fuel cell system for vessels. Scalability. This system right now, we designed it for 200 kilowatts, and it's really designed to meet power output, but also redundancy. We want to make sure that there's enough redundancy in the drive system so that if anything happens or you need to maintain anything, that the vessel doesn't stop. So there's a right amount of scaling and redundancy at this power level. Low life cycle cost is extremely important. So we use our latest FC Gen LCS stack. It's designed for over 25,000 hour lifetime with very, very low life cycle costs. They use carbon plates, so these stacks and the plates, they will last pretty much the lifetime of the module until the first major maintenance cycle, which is about 5 to 10 years. Safety, very important on a vessel. The module, like I said, is type approved, so that should help it make it simpler to certify the vessel. And there's dedicated controllers for safety. The enclosure is designed very unique so that it can manage all of the safety requirements for all the hydrogen components. It's designed for very easy integration. So in a vessel, there's a few things they need to watch out for. Where do they install it? It could be in an engine room, or it could be dispatched in the vessel because they have to manage the weight distribution. So with this type of system and this module size, we find that it's a good balance for most of the vessels that we're working on. And reliability, at the end of the day, the core technology is based on 20 years of heavy duty experience, 42 years of development. So, thousands of buses and trucks. So we know that the technology is reliable. It's all about how do we design the system so that you can use it in the marine space. So just a quick example that, how we could do this integration, right? You could integrate multiple modules coupled in electrical, you could couple it in parallel. And you can add modules all to get up to the megawatt scale. So 200 kilowatt is the module size, but we've seen cases with feasibility studies where we would look at, about 5 megawatts, and then, just trying different types of integration strategies. But that's kind of what we find right now is that we can integrate this to get to the megawatt scale for some of the larger vessels. So just a very quick example on a marine vessel right now, right? So the way people are generally doing the vessel, it's an electrical system that has battery and fuel cells. It's a hybrid system. So the hybridization is designed so that the fuel cell operates at the highest efficiency and the batteries take all the transient power. And then any time that the ship is operating at low operating requirements, then the fuel cell will charge the battery. You could use both to get maximum power, or you could use one if you're cruising. So it's this hybrid architecture that's going to work for these zero emission vessels. That will get you the best efficiency and best response time with the right level of redundancy. And the important thing is, as long as you have hydrogen, the fuel cell will produce electricity. So you don't need to have overnight charging or anything. You just have to refuel the hydrogen, and you'll get electric power. So some of our key marine projects right now, these ones are going to be in service over the next 3 to 4 years. Integration is starting right now. We're working with ABB at the megawatt scale for cruise ships. And it's a very new and advanced application. So we do have to work with industry partners for these ocean-going vessels. We're working with ABB as well on a river barge that uses about 400 kilowatts of fuel cell power. We're powering the world's first seagoing vessel, a ferry, in the United Kingdom. So that will use 600 kilowatts of fuel cell power under the High Seas 3 program. I think it's close to Scotland area. We have 2 ferry projects in Norway with Norled. So one of the projects, Norled is actually designing a completely new next generation ferry. The ferry will carry about 299 passengers, I think 80 cars, and we expect it to be the first liquid hydrogen powered ferry in commercial operation. So they're still working on this ferry right now. Again, the systems are being delivered, the vessel's being designed, and we expect integration to happen over the next 1 to 2 years. We're working on a river barge project in Germany right now, so you can actually see that publicly. It's a barge that uses about 300 kilowatts of fuel cell power, and then right now I believe they have already made some announcements, and there's some pictures and a video about that barge. So right now, all these projects, they're early stage, but deliveries have started. We've already started delivering fuel cell systems to the fleet, to the vessel designers, and integration is expected over the next 2 to 3 years. So, Ballard, just to wrap it up, we are a very long-term player in this industry. We have a lot of sustainable competitive advantages. So, we do make a very great partner for fuel cells, and we want to work with industry. We have a long history of working with different people, different customers, different partners. We see this to be a very global issue. So we don't want to do this alone. We want to work together with others. With Ballard, it's a very deep fuel cell talent pool. Most of us have been in the company for 10, 15, 20 years, some cases over 20 years, leading PEM technology, very comprehensive product portfolio, fully vertically integrated company, lot of field experience. So if you want to know more about fuel cells and different applications, we're more than happy to have some discussions and share experiences with each other. We have a deep pool of customers and industrial partners. So again, we want to work together with the industry. And Ballard is a very big brand. At the end of the day, we're one of the oldest in the world when it comes to fuel cells. A lot of companies know us. Our company changes a lot over the years, but the core of our technology and all our research hasn't changed. So again, very happy to work together on this, and look forward to kind of catching up with everyone. So that concludes my presentation, though. So thank you very much.
예, 정말 세상이 가까워진 것 같습니다. 이곳에서 발표하는 것 같은데요. 라이브로 참여해 주신 노만초 아시아 퍼시픽 어카운트 매니저 발표 감사드립니다. 다시 한번 박수 부탁드리겠습니다. Thank you for a good presentation, 노만초. 다음은 세 번째 발표자로
Next, we'd like to invite the third speaker from Hyundai Motem. Especially here, we're going to focus on a hydrogen tram. Mr. Lee Won-sang, please welcome me with a big round of applause. Hello, ladies and gentlemen. I'm Lee Won-sang. I'm from the Hyundai Motem. I'm also in charge of developing hydrogen tram. I understand you are interested in it, so I will show the technology development and then how the railways industry will apply the hydrogen in the future. Let me briefly introduce Hyundai Rotem. We are part of the Hyundai Motor Group. We are specialized in the Rotem, especially focusing on the defense and the tram trail industries. We are also covering the building the charging system too. In the future, we want to focus on supplying the hydrogen into the defense industry. Also, we want to cover the high-speed train area too. It was established in 1977. We have exported more than 40 countries. We have a full lineup in place. We have ambition to add H2 technology into our lineup. I think many visions of Hyundai were covered in the climate change and the series, the air pollution. We want to adopt the hydrogen technology that was shown in the next scene into the railway field. And then Hyundai Rotem was heavily involved in this process and effort. As you can see, there are many different types of the railway vehicles. Some depending on the speed, some depending on the power source. If you take a look at the power source category, so far it has been classified simply electricity motor or diesel, but from now on we want to add an other source of energy. This is a big trend we are facing in the future. Let me talk about diesel. Because we don't really have this type of the vehicle, tram will be the wireless. That's why it's our first choice. After tram, we want to expand our services and products into the different types of the railways. In line with that, I want to explain in detail. In Europe, there has been many research going on in the European countries. Alstom published the diesel-powered vehicle, and also this is the Chinese CRM has a pilot project. On the right side, Japan established for the first time. It didn't get popularity, but now Hitachi and Toyota tried to pick up that technology to introduce based on that existing technology. So there are many different types of the hydrogen railway vehicles from overseas. So with only the Korean technology, we need to develop more in this field. Let me briefly introduce tram. Anyway, tram is our main topic today. Actually, Hyundai Rotem vehicle is on display outside of this building. It can be used along with the bus on the highway. Once it's on operation, I think it is equivalent of the 175 vehicles. It's faster than vehicles. It has more accommodation of the passenger cars and buses. So it's like between the buses and then MRT. So the 20 local governments have been planning to introduce tram. It has been many covered in the new media. Ulsan also planning to adopt Dongtan tram, Seongnan tram. There are many local areas, local governments have considered tram as a part of their transport, mass transport system. So the first tram pilot project area will be where? I'm very curious about that too. Tram is different from the railway. As you can see on the right side, you can see the different technology between the left and right tram and the railway. The curve of the railway is different. Especially for low floor tram, we use the total axle. You can see that the D shape, so it can be used as an independent vehicle. But even though it's a low floor, all the parts and control system are actually located on the outside, as you can see in the slide. Motor control system bearing all out of the framework, so it's an inboard system. So technically, so it's a very challenging. And if you take a look at the railway, this is a buried into the ground. So French is normally inside, but tram, it covers inside and outside. So the hole is very small. So the vehicle width is very narrow. So it can be it cannot be applied in everywhere. We have to think about that challenge. So tram will be very potential in the city mass transport. So all around the world, tram has gained a lot of attention. It's economically viable and it's also environmental friendly. Especially, as you can see in the slide, given that it is on the highway, this is also a boost to the city revitalization and the city economy. Could you give me a moment for us to see the screen back? So tram. Usually have a wire tram system overseas market. They have to get the electricity from the outside, but locally in Korea, we are aiming for the wireless tram. So in big category, there are 4 different types of the trams. Generally, the traditional wire tram, also based on battery or super tram, wireless ESS tram, also wireless the hydrogen electricity tram. And the number 4 type is a combination, combined the wired and wireless hybrid tram. There are 4 different types, as I just explained. Okay, the screen is back on. The left one shows a wire tram. On the right side, we actually export this tram to Turkey. This is a combination hybrid tram. And also we are in the process export to Poland. If you take a look at the right side, there are 3 different modules. But basically, normally it's 5 different modules. It can be expandable up to 7 modules. Of course, 9 is also possible technically. We are participating in the bid to Canada with the 7 module. So there are 4 different types. So let me cover the different energy sourcing: battery tram, super capacity tram, hydrogen electricity tram. Battery tram, it has the maximum 30 kilometer for driving distance, but we have to think about air conditioning. So it means that in reality, it's only 10 to 15 kilometers to cover for one charge. And also charging time is long. But on the other hand, super capacity tram, it has a short charging time, but it covers 1 to 1.5 kilometers for one charge. So every station, we have to like a 10 minutes charging time. On the other hand, for hydrogen electricity tram, it covers 120 kilometers for one charge with a short, like 10 to 15 minute charging time. So with this hydrogen railway vehicle, we have a big impact benefits. we can think about two benefits. First, wireless effect. So we don't need a substation or high-powered wires. So it means that there will be very low infrastructure investment in the beginning, so it will not harm the environmental beauty. And also there will be lower maintenance cost. And we can aim for net carbon neutrality, and there will be no hazardous emission gas. And this will not only cover the short distance, it can be covered the longer distance. There will be less dependency on the passenger vehicles. And also that we can reduce the construction cost by reducing the other things. So let me cover the SWOT strategy analysis regarding the hydrogen electricity tram. We have a original technology. So if you take a look at SO, based on the semiconductor technology, they can be very efficient and powerful in the mobile field. We can be also world leading in this field. This can be the game changer. If you take a look at the WT strategy to secure the original technology in collaboration with the SMEs, we can aim for the going to global market. So technically, we have another benefits expected. It can contribute to strengthen competitiveness in hydrogen economy. So I think we can resolve many technical challenges, and economically also we can reduce cost. As I just mentioned before, the initial pilot costs will be also reduced. So in regarding LTC, it's a very effective, and also the societal perspective. Once tram is in place, I think it's like it can cover 280 passengers at once. Nesto is for just one small passengers, right? But with the tram, more people can share the hydrogen economy concept together. So, as you can see, there are different categories. So if you take a look at the wired and wireless, because we don't need the additional infrastructure, there will be the much benefit regarding the construction cost. This is showing the principle of the tram, the sucking of the air from the outside. There are three different levels of the filters. So it has an excellent air filtering function. So it can reduce the 99% of the air pollution from the outside. So it will create the clean air inside the tram. Additionally, currently the electricity cost is higher, but after a while, I think we can lower the cost to the level of the traditional energy source. Also, safety is also almost guarantee verified. So from now on, let me cover the already developed hydrogen electricity tram. I think it's been like 2 or 3 years. Hyundai want to the hydrogen tram concept car and want to imply to that to tram, and we have already driving tests, and we also have the verification demonstration business. We are aiming for commercialization in the end. So this has a wider than traditional bus. So this can be applied in the traditional conventional highways. And also, we connect two vehicles. And also, we put the 700 battery on top of the ceiling. So this is our concept car in development. This is about how we can charge it. As you can expect, so we have some legal issues regarding the battery. So we got the approval because of the thanks to the regulatory sandbox. We brought them to the special area for testing. So Hyundai engineers doing their best to develop further. So, but it's not finished. Based on this, we want to go more commercialization. This is our future task. I'll go back to it later. And take a look at the design. This can be very unique and beautiful. This can be the city landmark. We focus on the design too. In Changwon factory, so we conducted tests to cover the 15R. So with a certain width, we can cover it for operation. You thought this is a mock-up tram, but this is actual real tram. You can see the panorama screen that shows many different kind of information to passengers. So if you have time, please drop by to see our real tram. This is energy power net. You can see hydrogen energy is charged along with the battery and hydrogen tank. Our technology shows the lazy extender. The battery is the main and the hydrogen is additional. No, I'm sorry. It's the opposite. So hydrogen is the main, and only when if necessary, the battery can be used. And when only the power is needed on high gear, we use the battery. This is our method of development. What's challenging part in tram is that because we cannot put any kind of the mechanism below the tram, so everything have to go up to the roof. So we are using the ESS battery over here, and hydrogen battery will be located in this area as I showed in the slide. So this is a flexible. We are thinking about this possibility. So based on the concept car, along with the government, Ministry of the Commerce Industry, we've been conducting pilot projects since July. I think it will be wrapped up by 2023. We are in charge, along with the Korea Automobile Research Institute and Korea Railway Research Institute and Ulsan TP are all part of the collaboration. So we are also thinking about sizing repacking. We are also developing the battery pack accordingly. We're also thinking about flexible tube, cooling system, storage module to increase the efficiency. PMS system has been developed along with the inverter, and the total control system are all in place for future development. And along with the 22 stakeholders, including the SMEs and the research institutes, we are moving ahead with the R&D. So we are coming up with a better equipped technology, and that has tested in Ulsan, and that has been verified in Ulsan. That has been the project we've been covering. By the end of the 2023, we will manufacture the tram, and we will target to operate this tram for Ulsan citizens. So 4 major stakeholders are doing their best to realize this vision. Let me cover the layout. 3 module, 20 meter. This is a Polish Java trap I explained before. Eventually, we will lower the floor. We will go for longer haul tram, covering the 35 meter in length. If we realize that, so it can accommodate 310 people. So at least we will aim to accommodate 250 passengers. With the hydrogen electricity trams, I believe we can even apply this into other fields, especially regarding the wireless trams features. I believe that electricity hydrogen tram can be used beyond the inner city mass transport mode accommodation. Also, actually, even Ulsan, the KTX is located pretty outside of the city, so then we can connect this outskirt area of the KTX is located to the main city with a tram. For example, Jeju inner circle route can be adopting hydrogen tram. So I wonder if you have any other questions. I think it's mainly the questions regarding the fueling, charging, the infrastructure. We have a factory in the Dokjong. As you can see on the right side, they have a combined fueling station as a pilot project within the station. If there's only one hydrogen charging station, there's no other station needed in the city. Given that it's a combination hybrid charging stations, so it can be used for tram, but also for other mass mode of the transportation, such as bus. This is the power roadmap regarding the tram. So this is a 1, 2, 3 steps. So in the second step, we will apply 1 to 2 megawatt. In the third step, we aim for 3 megawatt. That will be the level of the conventional rails and the highway rails. So that can be used on module parallel. So I just covered the whole roadmap briefly. So in 3 years, I think once tram is developed, I think we can use this technology to other fields. So high-powered vehicle can be also following suit. So by combining 6 modules for tram, this create a power that can be used 1x of the diesel. So it means that we need 6 axes. So by 2027, I believe even we can adopt this technology for the route between South and North Korea. Given that we have a different frequency, actually currently, we cannot use the electric vehicle, so we have to depend on diesel vehicle only. But so it means that environmental damaging. So in the future, we can adopt this technology to have a cleaner route between South and North Korea. Thank you for your attention. Thank you for the great speech. Please give him a big round of applause for the great presentation. So in 2023, I believe the Ulsan will conduct the demonstration project. I hope that we can see the demonstration in our next year's expo. I also apologize for the delayed screen, but I believe the YouTube can see the screen properly. I'm sorry for the delay and technical glitch. Next, I'd like to invite the speaker from the special session, Kim Dong-gyu,
Director of the Investment Promotion, UFEG, will talk about the strategy on the inducement of hydrogen-related institutes and businesses. Please welcome with a big round of applause. Good morning. I'm Dong-gyu Kim, a Director of Investment of Promotion of UFEG. Since this is a special session, so please enjoy my presentation. So let me share the promotion video first, and then so there are a lot of people who don't know much about the free economic zones. I will briefly explain what free economic zone is, also the conditions for UFEZ, and also the plan that we put together to induce investment for 2021, also major projects. So let's take a look at the video clip first.
울산입니다. 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 미래를 만듭니다. 울산의 힘, 한국의 미래. 울산 경제자유구역. 20세기 대한민국 산업을 이끌어왔습니다. 이제 울산은 21세기에도 새로운 제도약을 위해 울산경제자유구역을 시작합니다. 역동적인 울산의 저력을 바탕으로 대한민국 산업수도 울산이 힘찬 미래를 만들겠습니다. 글로벌 경제특구로 탄생할 울산경제자유구역은 수소 기반의 에너지 산업을 중점 유치 대상 업종으로 설정하고 이와 연계한 혁신성장 산업 육성과 생태계 조성을 통해 울산과 대한민국 산업의 미래를 만들 것입니다. 울산경제자유구역은 크게 세 곳의 지구로 구성됩니다. 먼저 테크노 상단에 위치한 수소산업 거점 지구는 수소산업의 앵커로서 수소산업 실증화와 연구시설을 집적화하고 수소경제 선도도시를 만드는 데 큰 역할을 할 것입니다. 이화 일반 상단에 위치한 일렉트로겐 오토밸리는 수소자동차 부품 산업에 주력하는 지구로 앞으로 수소자동차 부품 생산시설을 유치하여 친환경 자동차 부품 클러스터를 형성할 것입니다. 울산 하이테크밸리와 유니스트 등이 포함되는 R&D 비즈니스밸리는 지구 중심에 KTX 역세권이 위치한 장점을 살려 연료전지 연구와 관련 R&D 기술 개발에 주력하게 됩니다. 나아가 비즈니스 지원 산업을 육성하고 글로벌 스탠다드 환경의 정주 여건을 조성함으로써 최고의 투자 환경을 갖추어 나갈 것입니다. 동북아 에너지 허브 울산은 수소 에너지의 시대를 앞서 열고 있습니다. 수소 생산 전국 1위인 울산은 130km의 수소 배관, 10개소의 수소 충전소 등 최고의 인프라가 구축되어 있습니다. 아울러 수소 연료전지 등의 실증화 센터를 운영하고 있으며 수소 생산 경쟁력 강화를 위해 인센티브 제공과 규제 완화 등 다양한 정책적 지원을 통해 혁신 생태계를 구축해 나가겠습니다. 앞으로도 울산은 수소산업 10대 추진 과제, 수소 연구개발 서비스와 기반 조성 4대 사업 추진을 통해 대한민국 수소산업의 현재와 미래를 책임져 나갈 것입니다. 울산경제자유구역은 개발과 투자 유치에만 만족하지 않습니다. 유망기업은 더 튼튼히 키우고 연구개발은 가장 앞서가며 핵심 인재는 함께 키울 것입니다. 이를 위해 울산경제자유구역이 함께할 것입니다. 울산은 수소산업과 함께 동북아 에너지 허브로 도약하는 한편 부유식 해상풍력과 원전 해체 기술을 선도함으로써 대한민국의 미래를 만들어 나갈 것입니다. 울산의 힘, 한국의 미래, 울산 경제자유구역.
So you've just watched a video quickly, but still you don't know what this is much about. So it's been more than 10 years since I worked as a public officer, and I began to learn about FEG. And then, so let me briefly explain. So you may think about Songdo or Yeongjongdo when you think about the FEG. So there are parks, also factories and residential areas and apartment complex and foreign companies. It's like a new town, or it's like a new complex. So everyone working in our authority is actually public officers. So you can see the definition by law. So free economic zone is a special economic area to induce a businesses proactively by providing a decent working living environment, also offering autonomy and as well as maximum inducements and deregulations. So we offer tax benefits and business activities. We support business activities as well as deregulations and one-stop services, and also support administrative activities. So people tend to confuse with a free economic zone. Actually, Ulsan has free economic zone as well. And free economic zone is like a specially designated area to offer incentives to businesses so that it can induce factories for export. But if you look at free economic zone, it offers business support as well. Also, it provides complex infrastructure, including housing, medical services, education, broadcasting, finance, and so forth. So there has been a lot of changes in these strategies recently, and the Ministry of Trade, Industry, and Energy announced the Free Economic Zone 2.0 vision and strategy. There has been some changes in these strategies, and in the case of Incheon Metropolitan City, they actually purchased the land and reclaim the land and make a complex. But actually, the strategy is now to make a mecca for exports. So we used to provide incentives to foreign companies only, and also domestic or onshoring companies only. But now the strategy is to provide benefits to cutting-edge companies and high-technology companies, as well as core strategy industries. So the direction is slightly changed. And so not just for foreign companies, but also domestic companies should be able to enjoy incentives like tax cuts or tariff cuts or national tax cuts. So all those benefits will offer both to foreign companies as well as domestic companies. So you can see there are 3 districts, and the size is about 4.7 square kilometers. We will add additional districts in Northport and some other areas, so this area will continue to expand going forward. And the vision is to make Ulsan as a Asia hub in Northeast Asia. And you see the target is actually, you can see we have high or bigger interest in domestic companies as opposed to foreign companies. So let me briefly summarize this. And Ulsan has many automotive, shipbuilding, petrochemical industry here, and also we also have a special economic district designated in Ulsan area. Due to time constraint, I will skip this part. And so let me explain our objectives and basic direction. And first of all, the target is to induce new industries. So we'll focus on hydrogen industry so that we can make a transition to hydrogen-based society. And also, energy trading and also nuclear plant decommissioning industry is our target as well. Also, in order to make a healthy environment, actually, we have large companies as well as manufacturing companies in Ulsan. So we try to induce R&D and startups as well. And if you look at living environment, so there is a legal basis to have international schools in free economic zone. So we will proactively attract the international schools here in FEZ. And in the past, the focus was on inducing foreign investment. But considering the foreign reserve, rather than focusing on foreign investment, it's better to induce foreign companies and Korean companies which serve our interests the best. And also, there are many Korean companies which are in competition with foreign companies. So rather than simply inducing foreign companies, it's better to actually support the Korean business and companies. So we put together strategies and tasks. So strategy 1 is the selection and concentration. Since we don't have enough time and resources, so we need to target, we need to pick and choose the type of companies that we try to induce. And secondly, we cannot do this alone, so we need to work together with a central government as well as other relevant authorities. And the strategy 3 is a customized marketing. So we actually visit the companies and we try to listen to their grievances and complaints so that we try to address their concerns. And next strategy is a managing the company or supporting the company rather throughout the life cycle. So from the very early stage of discovering or identifying startup, and I'm going to give you more details later, so we can match those startups with large companies. Also, we provide one-stop services to the companies. So I already explained this, so let me move on to the next slide. So I'm here actually to promote this. Early this year, we launched a hydrogen technology cooperative open platform. We do have a lot of large companies operating in Ulsan. And so there are many startups and many small and medium companies who want to work together with the large companies. That's why we came up with this project. So actually the prize money is not that big. We award 5 million won. So we provide opportunity for cooperation and partnership. Also, we provide mentoring and consultations as well. So if you look at the processes, so it's a little bit different from other project because so we actually publicly reveal the technologies that the large companies are interested in, and then we have these competitions and make evaluations and select a target SMEs. We selected 8 companies so that we offer them an opportunity to cooperate with the large companies. And so if you go to the first floor, you can see 5 companies out of 8, and you can see more details about those 5 companies. So I'd like to ask you to provide a lot of interest and support to these companies. So these are basic information about those 5 companies, or rather actually 8 companies, and you can see more details on the first floor. That's it. Thank you for listening.
A warm welcome from my side to the presentation of AVL's view on fuel cells for civil and military applications, focusing on the challenges and solutions. I am Josef Macherhammer, Product Manager for Hydrogen and Fuel Cell, and I'm glad to get the opportunity to present this topic to you. Let me start by giving you an overview of what I'm going to show today. First, I want to show you some reasons and motivations to use fuel cells, the focus areas of development, and the most relevant technologies. Every technology has its challenges, but also its solutions. The same counts for fuel cells. I will try to summarize the major challenges which can be solved with fuel cells, but also arise because of using them. All of them need to be addressed, and I want to give you an idea how this could be done in the last chapter. AVL is the world's largest independent technology partner for the development, simulation, and testing of powertrain systems, as well as innovative automotive solution concepts. We have 3 disciplines under one roof: engineering services, instrumentation and test systems, and advanced simulation technologies. One of our doctrines in AVL is, we owe it to the planet. It's our duty as an organization to contribute to the resolution of social, cultural, and global issues, especially with regards to environmental protection, sustainability, and global emission reduction. Following this credo and driven by our pioneering spirit, AVL decided already 19 years ago to build up fuel cell know-how and competences. Since then, a lot happened. Today, AVL provides its own fuel cell IPs and delivers high-end customer-specific engineering, testing, and software solutions for PEM fuel cells, SOFC, and SOEC technology. The motivation to use fuel cells is strongly dependent on its application. Civil applications are typically focusing on economical, ecological, and political and social aspects. Currently, the taxation of CO2, local bans of ICE, heavy funding, significant private investments, and also alternatives to stabilize the grid are pushing the technology forward. Military applications are concentrating on other fuel cell attributes. Performance increase caused by electrification, very silent and stealth mobility. A fuel cell offers about 80% audible reductions and 90% reduced thermal signature compared to an ICE. Additionally, fuel cells can use a variety of fuels and very high electrical efficiency for decentral energy production. If one needs to summarize the currently needed development areas for these 2 applications into one word, it would be cost for civil applications and robustness for military applications. Civil applications are currently facing the challenges of the industrialization of low-cost and large-scale fuel cell productions. Establishing a reliable supply chain, which is always linked with a significant development effort, and the creation of an affordable fuel infrastructure is one of the significant tasks. Military fuel cells applications need to cope with extreme environmental conditions and unpredictable duty cycles. This leads to a wide range of operating temperatures, from very cold to extremely hot, contaminated and toxic air supply, and significant mechanical stress, which might be caused by ballistic shocks or extreme off-road conditions. One fuel cell technology does not cover all of these areas. Therefore, AVL's view on the mainstream technology roadmap 2030 plus is built on 3 pillars: high-performance polymer electrolyte membrane or proton exchange membrane PEM systems for power, a variety of mobility applications. The high-temperature solid oxide electrolyte fuel cell, also known as SOFC, for decentral power and heat generation. And last but not least, the solid oxide electrolyzer, SOEC, for hydrogen and e-fuel production. Let me elaborate why we select the just described technology pillars. PEM fuel cell technology offers a great power density, even better than an ICE, shows very quick ramp-up times and good dynamic responses. Sufficient for all mobility applications, especially in combination with a small battery pack. It operates at low temperature, up to 80 degrees Celsius. In the contrary, it needs very high hydrogen purity and an expensive platinum catalyst, and additionally a sophisticated cooling concept compared to an ICE. The SOC technology can be used to produce hydrogen and power. SOFC has a peak electrical efficiency greater than 55% and is capable to handle a variety of fuels like hydrogen, ammonia, and methanol. The SOC stack technology operates at temperatures sometimes significantly above 500 degrees C. You want to keep this temperature as low as possible to reduce the component requirements significantly. High temperature is very favorable for heat and power coupling and also for e-fuel production. If you want to use this technology, you need to handle the low power density compared to an ICE and PEM fuel cell, the long ramp-up times, and the challenging component requirements. Every technology has its challenges, but also its solutions. The same counts for fuel cells. Let me start by summarizing the major challenges which can be solved with fuel cells, but also arise because we use them. Energy storage and security will greatly affect our society in the future. Establishing energy security will be essential for civil as well as military applications. To achieve this goal, it is essential to reduce dependency on fossil fuels and the logistic footprint. Additionally, you need to be capable to use alternative energy sources, especially for remote locations. The air and noise pollution should be reduced to a minimum, and the system should be flexible enough to combine them to microgrid applications. Durability and robustness are key criteria for all applications. Achieving a long lifetime is of course dependent on the operational profile, but a major effect comes from the control strategy and the fuel cell hardware itself. A 10% loss in net power is defined as end of life for a fuel cell. Reducing and predicting the degradation of a fuel cell is essential to ensure high efficiency and predict maintenance. I want to give you some examples of topics which needs to be considered. The formation of hydrogen peroxide needs to be controlled to keep the chemical stability. The generation of water needs to be controlled to ensure optimal humidity and no blocking of the channels. And hotspots needs to be avoided at all costs because they lead to thermal stress and chemical degradation. For PEM fuel cell vehicles, cooling is a very critical topic. A PEM fuel cell has about double the cooling demand and even a lower temperature level compared to an ICE engine. Sophisticated thermal management, considering all the relevant vehicle systems like battery, transmission, cabin, and so on, is needed to cope with this challenge. The effect on system efficiency, driving range, durability, and comfort should be reduced to a minimum. The integration of the fuel cell into a vehicle brings a lot of challenges. Interestingly, it's not the fuel cell system itself which makes it very difficult. The big drivers are the integration of the thermal system and the integration of the tanks. Challenges that come to mind to ensure the airflow through the dense packaging, make the space for hydrogen tanks, which are about 10 times bigger than a diesel tank if you want to store the same amount of energy, and the integration of large battery packs, especially in the demand, if you demand high recuperation. All of these challenges can be solved, and I want to give you an idea how this could be done. Successful development is built up on three pillars: engineering, simulation, and testing, which must be interlinked and are all equally important. Defining, tracking, and achieving all requirements, considering subcomponents, components, and the system and its integration into the application is a great challenge. In AVL, we have built a product and service portfolio which is strongly interconnected to support the whole development process. For fuel cell subcomponents development, we are using our own CFD software Wed-Fri, and we have dedicated testing solutions in place to validate the simulated performance. The same counts for individual components, the system and its integration. We are using AVL Cruise and Cameo to simulate and optimize the system performance and test everything in a hardware in the loop or model in the loop environment. To illustrate this process, I want to show you some practical examples. AVL has successfully developed a modular fuel cell system which can be integrated in different vehicle platforms. The sizing of one system was chosen to decrease power density and the weight effect on the weight to a minimum, but to improve system efficiency and durability to a maximum. Using smaller fuel cell systems increases the access to a feasible component supplier base and creates a redundancy, which reduces the risk of a complete system shutdown. One of our development goals was to additionally build and demonstrate a very power-dense and compact fuel cell system, because high power density enables highest efficiencies or a cost reduction potential due to downsizing. To illustrate the very competitive KPIs, we have compared the AVL high-track fuel cell demonstrator with public data sheets of available and announced truck fuel cell systems. Let's compare our system with a global premium OEM in the middle of the pack. Based on our assessment, the AVL fuel cell system demonstrates a 40% greater power density. It is not the power density of the stacks which makes the difference. It is the integration of the balance of plants components and the form factors. AVL is also planning to put the fuel cell system on the road. The virtual integration simulation is already finished and the 300 kilowatt fuel cell system is installed. We are using an existing track platform and adapt it based on the specific fuel cell needs. To solve the cooling challenge, we had to increase the front radiator surface by 180% to 1.8 square meters, and we had to optimize the cooling airflow. Additionally, we had to add radiators on the sides to cover worst-case operating conditions. It is planned to see a prototype truck with the AVL system installed in action in 2022. The technology readiness level of the SOC technology is not as advanced as the PEM technology, but it is catching up. AVL is currently or has already developed prototypes to prove that SOC technology holds up to its potential. A durability greater than 2,000 hours was validated using the AVL in-house developed software. Multi-fuel capability and highest efficiencies were demonstrated, and different stacks platforms were integrated. AVL, as an independent system integrator, has very good relations with all SOC stack suppliers. But with, for example, Ceres Power, we have signed a collaboration agreement to further speed up the prototype build-up and industrialization projects. In parallel to our prototype builds, which can be ordered now up to a megawatt scale, we are working together with customers and partners to get large-scale commercial products ready around 2025. Based on our opinion, the SOC technology will be a game changer for efficient and clean power generation, as well as hydrogen and e-fuel production. Finally, I want to summarize and conclude what I've just presented. AVL mainstream fuel cell technology roadmap focuses on PEM, fuel cells for mobility, and SOC technology for power generation and e-fuels. A reduction of cost, especially for civil applications, and increase of robustness for military applications is essential to establish the technology in large scale. The major challenges which can be solved with fuel cells but also arise because of using them are energy storage and security, degradation over time, cooling and integration. A holistic development approach supported by a complete tool chain in the areas of engineering, simulation and testing is needed to find the most optimal solution. Thank you for your attention.
네, 감사합니다. 영상
Thank you very much, Mr. Yoko Mark. Thank you very much for sending this video clip for us. Next, I'd like to invite the next speaker, Greg Harris from Intelligent Energy Sales Director will cover the topic for developing high-power fuel cell systems for automotive applications. Please give him a big round of applause.
Good morning. I'm very pleased to be here today to talk to you. Thank you for the organisers to invite me here to speak with you. The support of the British Embassy, who have enabled us to display some of our products in the exhibition, which I hope you will visit later on in the British Embassy stand. And also our local partners, Ho Green Air, who are helping us to work with Korean customers on our range of fuel cells. So for me, it was very important to come to Korea. It has been quite difficult to travel at this time, as you can imagine. But when you look at Korea and its focus on hydrogen, it demonstrates to be one of the most progressive countries in the world, with more fuel cell vehicles on the road, thanks mainly to Hyundai, than anywhere else, and the biggest rise in the number of hydrogen fueling stations as well. So for me, it was very important to be here today. Back in the UK, many people will be aware that they have the COP26 summit as well, with leaders from all around the world talking about climate change and how to address that. But I'm pleased to be here today with other speakers to talk to you about the practical ways in which we can address that, rather than the politics. So what we've seen recently, let's say in the past 2 years, is a focus back on fuel cells and the potential for use in automotive applications. So particular companies, Toyota, Hyundai, Honda, have continued to work on fuel cell technology, but for many other companies, there was a doubt and a particular focus on battery as the main drive for zero emissions. However, as batteries have been applied into a range of automotive applications, there's a realization that they're limited in what they can do, particularly in terms of the range, achieving long range without very heavy vehicles, the challenges around the utilization, the necessity to charge the batteries and therefore limit the length of operation, and also questions about the sustainability and the supply chain for batteries, where the chemicals come from to produce them. So what we've seen now is OEMs now looking again at fuel cells for automotive use, and it's not just the companies that develop their own technologies, but manufacturers that now want to use fuel cells in their vehicles and creating joint ventures or sourcing them from manufacturers like ourselves. Particularly, those benefits are being seen into larger vehicles where batteries will make them very heavy, and taxis as well, where you have a challenge in the duty cycle, and also into heavy duty and long range commercial vehicles. Challenges do remain. The most significant, I would say, being the infrastructure, which actually, as mentioned, in Korea, you're very progressive moving forwards with that. It's not the same in the UK and other countries, unfortunately. The cost and the greenness of hydrogen are also significant, and the challenges there have to be addressed to see this wide-scale take-up. One of the biggest factors that we can see is the total cost of ownership as well. So particularly for commercial vehicles, this is well understood, but actually changing the mindset of the passenger vehicle owner, that maybe you pay more for your vehicle at the start, but actually the cost and benefits of running the vehicle over time can make that a good choice. So based on predictions in terms of cost reduction for fuel cells and the future price of hydrogen, we expect to see that already by 2025, long-range passenger vehicles can be competitive with hydrogen compared to battery of electric vehicles or diesel. With trucks, this is coming perhaps potentially even sooner, because such a large component of the cost is the operating, and with low hydrogen cost, this can become a very good alternative. And with fuel cell buses, even very long distance buses, you can already see that hydrogen can be a good solution, but we expect to see that accelerate over time as well. So there's many markets where hydrogen and fuel cells are being seen as a very cost-effective solution going forwards. So I wanted to talk about some of the projects that are going on in the UK to give some examples of the activity where Intelligent Energy is involved and collaborating with other companies to move forwards the development of fuel cell technology. In the UK, the Advanced Propulsion Centre is a major funder of projects, and we are fortunate to be collaborating with Chang'an, which is one of the largest manufacturer of vehicles in China, as well as one of the UK's major producers of buses Alexander Dennis. And this project has enabled us to develop our fuel cell system in two variants, one for passenger vehicles and one for use in buses and trucks. And that project will also fund the next stage of accelerating the production for volume manufacturing of our fuel cell systems. We're also seeing the commonization approach towards fuel cells, and I think this is very important. It's something that batteries have never really achieved, but we are working together with some of the other companies you'll hear from today and others in Europe on a common approach to the fuel cell development. What this means is that those manufacturers will provide fuel cells with the same physical dimensions and interfaces so that a manufacturer can choose a fuel cell from its preferred supplier without having to specifically develop their vehicle around it. There will still be room, of course, for product differentiation in terms of performance, efficiency, and mass reduction, in terms, improved power density, but within the framework that allows manufacturers to more easily choose the supplier that they want to work with. And that includes not only road, but it's bringing in a number of manufacturers from other sectors as well to, as far as possible, have a common solution. One of the other key areas, and one of the biggest challenges, in fact, is the development of heavy-duty trucks for fuel cell use as well. So, development of zero-emission heavy-duty trucks is one of the big challenges. And it's well recognised that the only real way to achieve that will be using fuel cells. We're involved in a project in the UK that is focused on the feasibility of developing heavy-duty trucks for the UK's logistics requirements. And in fact, just yesterday, the UK announced that it will be the first country in the world to set specific deadline for zero-emission trucks. So from 2035, all trucks under 26 tons will have to be zero emissions, all new trucks. And from 2040, that will be extended to all trucks, everything including heavy goods vehicles. So I think this just indicates that the requirement is there to offer these type of products going forwards. So that's a bit of background into the why and the focus on automotive. Just a little bit of background on the company, Intelligent Energy. So we're a UK-based independent company, privately funded. We've been developing fuel cell technology for more than 30 years. With a very strong focus on smaller and lighter products, high power density fuel cells. And we're providing those products for a wide ranges of markets using our own patented fuel cell technology. So our range of products goes from very small, very light, power dense, air-cooled fuel cells, which we apply into a range of applications, but particularly into drones. And if you visit our stand downstairs, you can see one of the drones from Ho Green Air with our fuel cell integrated. And that's actually the highest power density air-cooled fuel cell that anyone produces for that market. We're also delivering fuel cells for a range of other small applications, so things like forklift trucks, small stationary power, UPS systems, etc., from our IE lift range. And then we have our high power range, which we'll talk about further, which is providing high power solutions up to 100 kilowatts for each fuel cell system. And that's mainly focused onto automotive markets. So just to give a bit of background, we have a long history in terms of activities in fuel cells for automotive. We installed our fuel cells back in 2012 for the London Olympics, and vehicles ran for over 4 years and over 100,000 kilometres. We also installed them in vehicles that were running in the Netherlands as well, and worked with Suzuki under a joint venture to trial fuel cell scooters as well. More recently, we've been engaged in the development of our latest product range with a heavy-duty truck company in China called KHIA, and as mentioned before, working with companies in the UK and China for developing our modular fuel cell systems. So when we talk today, most of the companies will talk about PEM fuel cells with liquid cooling. So we have a somewhat different approach. We actually use evaporative cooling in our fuel cells. This effectively uses the latent heat of evaporation to provide the cooling rather than a separate liquid cooling. So it effectively combines the humidification with the cooling system. The benefit of that is that you reduce the thermal lag in the system, you reduce the mass of the system because you don't need separate liquid cooling plates, and you also reduce the balance of plant as you don't need a separate humidifier. It also brings benefits in terms of the thermals and allows us to have reduced the size of the radiator that's required to provide the cooling for the system as well. So if you compare a liquid-cooled system with our evaporatively cooled system, as mentioned, it removes the cooling plates, the humidifier, and it also brings benefits in terms of increasing the power density and reducing the components, improving reliability, but also improving the cost overall as the amount of materials required are reduced compared to a normal liquid-cooled system. So the two products have been developed in parallel with each other. So our HD system, which as you can see is a rectangular modular system, which independently each system's providing 50 to 80 kilowatts, and multiple systems can then be set in parallel to provide 500 kilowatts or more as required, depending on the application. So this allows us to meet all the motive applications, but also larger stationary power applications as well. And in parallel with that, we've been developing the engine block format of fuel cell, and in 2022 that will start to be integrated into passenger vehicles with Chang'an. But what we're also seeing is a real interest in the same fuel cell technology across a wide range of markets. This simple modular format meets the requirements from all sorts of applications, particular demand for stationary applications, for stationary power, as part of a zero emissions or hybridized power generation solution. But we're also seeing increased interest in implementing this into rail, into marine, and other areas such as off-highway or construction, as legislation starts to push for reduced emissions in a wide range of markets, as mentioned by some of the previous speakers, in fact. Summarising the HD product, it's a complete system. It includes all the balance of plant, so it's not necessarily the case when you go to other suppliers that you will get provided with a complete system that's simple to integrate. It's designed to provide a range of net power outputs from 50 to 80 kilowatts, and that's reflected in the life of the stack. So obviously higher output will reduce the life of the stack, lower output will increase it. It has the capability to provide a peak power output of up to 97 kilowatts, and as you can see, a high efficiency. So just Adding to that further, the system as supplied comes as a main module, which you can see integrated into a truck here, with separate thermal module, the condenser, exhaust, air filters, and DC-DC. So the system can be provided complete and ready to integrate into all sorts of applications. And here a specific example of it being installed into a heavy-duty truck. So this is actually one side of the truck, and the opposite side is the mirror image. So this vehicle is using two systems to provide up to 160 kilowatts of power from the fuel cell, and just a small battery to manage some of the transient loads and requirements, and allow the vehicle to do regenerative braking as well, of course. We're also focused on the future markets as well. And I think this is quite important because, as mentioned by AVL in the previous presentation, achieving the highest power density is really critical to getting the cost down and making the fuel cells suitable for all applications. Aerospace is recognized as one of the biggest challenges in terms of achieving zero emissions. And whilst there is discussions about capturing carbon and fuels that are carbon neutral, in terms of in-service zero emissions, fuel cells are recognised as providing the best solution. Within this project, with GK and Aerospace, Intelligent Energy is focused on developing the highest power density fuel cells in the market, way beyond anything that you can buy today. And the EC technology actually enables us to do that because of its ability to have a high power density. We also see this focus on aerospace will also support us in terms of improving the power density on the other products as well, with many of the technology being developed then brought back into automotive and other applications, so they can benefit from that technology advances. So it's a very interesting project, and we're very pleased to be a key part of it. So just summarising really, so Intelligent Energy, 30 years of fuel cell development experience, proven experience within automotive. We're now able to offer customers in 2022 our latest generation of fuel cell for heavy duty and passenger vehicle applications. We are investing in the UK manufacturing facility as our primary location, but we're also looking into markets such as Korea, where we expect to see the demand, and we'll be looking at how we can provide local manufacturing as well to meet those market demands. The technology we have makes our fundamentally smaller and lighter than alternatives, and also competitively priced, with a roadmap to see that cost come down significantly over the coming years. So thank you very much for your time. I hope that was of interest. If anyone would like to see some of the technology, please visit our stand and the British Embassy. But thank you for your time.
예, 예, 고맙습니다. 그레그 해리스.
Thank you so much, Mr. Greg Harris. Please give him a big round of applause.
We invite the last speaker for the second session for hydrogen mobility, H2WORLD from Vincent. He would like to talk about the power management system development and production for shipment, hydrogen fuel cell hybrid type. Please give him a big round of applause. I'm H2WORLD from Vincent today. I think the slide will capture the topic I want to say. This isn't cute. I think everybody wants to try it. We are developing this type of the shipment in regard to hydrogen as an energy source. And then we can be applied in the large scale ship. I think that the shipment covers 90% of all the logistics of the world. I think this is the future we have to think about. So already, according to International Maritime Organization, there has been many talks recently. Marine Environmental Protection Committee decided that by 2026, including the old existing shipments, every shipment have to reduce the carbon dioxide. Actually, HFO cannot be enter into the Nordic area, and that has been in the process of being regulated. And also, there are more and more projects from Korea. We are, I think, established #1 in this market. And most of the ships, large scale ships, how they can deal with this issue, we have to find a solution because it's not even the proposal of the solutions. So before 2026, I think we have like a 4-year time to prepare. Then how can we resolve this issue? There has been ongoing talks, including ourselves, and in collaboration with the ship owners, we are thinking about how we can resolve this issue. I will show you with a concrete result. If you take a look at the big result, according to the international agreement, we want to target zero emission, but it cannot be just happening overnight. We have to do step by step. This is a phase-in agreement. But if you fail to accommodate the regulation, you will pay the penalty. To deal with this penalty, we have to think about technology or speed. There has been many alternative options. So, for example, in Japan, there are many ships pilot as a part of pilot project with a battery attached for the short distance route. So they announced regarding the plan. And when it comes to like a luxury mega boat, where like a rich people use it for cruise, main engine is in diesel. So already the diesel cruise order has been dropped by 50%. Because it's actually not a good time to have a diesel-based cruise. That's why many people are seeking out the solutions. So there has been some delay hiatus for the market. However, the market will go back to normal, we believe. Then we have to think about hydrogen. Is it really commercially viable solution for shipbuilding industry? UN, IMO, all these international organizations and national governments announced that they target to reduce the hydrogen price from $8 to $2 by 2050. And as soon as possible, they want to lower the price as much as possible compared to gasoline or ICE. I think this price can be competitive enough regarding the power density. I briefly mentioned the large scale vessel. What about the large scale vessel market? What about how big the market is? I think it's 14 trillion won. And every year, I'm talking about every year, it's a 14 trillion won market. The biggest engine players are Dachilia and Manengin. These are two biggest players in the market for engine market. But no one is ready for the net zero technology. But nowadays they are using the ammonia for high propulsion. This is a new technology they've been tampering with. Of course, it has also negative side because ammonia also emits the hazardous chemicals. So we want to go for environmental friendly, highly efficient vessels. So this technology has been developed, and that has been tested on the small vessels. As you can see in the slide, at first we tried the electronic propulsion module. Next, we tried the lithium-ion battery pack. If you take a look at the upper side, it's actually 100 kilowatt. That has been used for Tesla. The next one, below one, is a 92 kilowatt for megawatt level scale up. So battery, they need a certification for the marine application. Third, it's about fuel cell module. The upper picture shows a 120 kilowatt module. This is only dedicated for the marine application. The below picture shows a 0.5 megawatt module that can be stacked on parallel. It looks great visually. But how can we configure efficiently? This is a study ongoing because we need a system to control in harmony too. Then, how the future will show the high-end technology. Currently, HF4 type with a large scale engine have been used. That's why we need a big crane. So they just use one big unit inside. In a big cruise, they normally have 4 to 5 big engines. It's like having a big 4 buildings inside a big, large vessel. Then how it can be changed? VACC with a big oil tank, 30 kilogram. Then they require a 20 kilowatt output. LNG carrier requires 30 megawatt energy propulsion. And there was been a container issue recently. They require a 70 kilowatt on average. As Rotem mentioned, and that has been application in trucks, 1 megawatt. But for the larger scale vessel, it requires a bigger than that for energy source. Then how can I implement that? AVL, Hyundai, Toyota, I think come up with the good solutions. In our case, thanks to the support from the Hyundai, we are using the new restacking scaling methodology. I think there's one part no one touched upon yet. Many people say scaling up to go for the heavy duty. Then what about energy? No one is talking about that issue. For example, let's say the vessel has a 10 megawatt to 10,000 horsepower. It means that it have to go non-stop on the route. But with the hydrogen energy source, fully charged in the tank with a lot of the stacks, it feels like the vessel is carry them around. It will eat up the space in cargo. So the space is supposed for cargo, not for the hydrogen tank. And the liquid hydrogen, it will be the solution. Capturing them in the liquid hydrogen into the storage. Is it a viable solution? If really? In the low temperature, can we really keep them well in the storage with a low cooling temperature? Because so far there's not proper facility for that. This is one other issue regarding that. So all the core technology, such as a membrane in fuel cell, will increase the efficiency. And they can be used in commercial trucks. I understand that. But to have a really meaningful reduction of the footprint, we have to think about the fundamentals regarding the energy issue. So, for the past 1 year, we have conducted the research regarding that, how we can supply energy in a stable way in collaboration with the shipment owners. So internally, we reached the consensus to use the ammonia. By utilizing the features of the ammonia, the kit itself is the energy. It's not energy carrier. It itself is already energy. We don't call an oil as an energy carrier. It's an energy cell. Same with the hydrogen. It's about how we can carry and store this energy for utilization. For that, I think the ammonia comes in. According to international organizations, ammonia has a seen as a hydrogen carrier. Then how we can create the ammonia in a green way, how we can share with other parts of the world. That has been the ongoing concern by the UN too. So we have to produce the electricity, but it's not possible to use that only with the hydrogen because it has a facility issues in the port because we don't have an infrastructure yet. It will not be possible to establish all the necessary infrastructure within a few years. However, on the other hand, ammonia has been already produced over 20,000 units. I understand this is a toxic chemicals, but ammonia will not kill human beings in any worst case scenarios. So I know this is toxic chemicals, but we can handle it in a safe way. So our solution for it is the bunkering with ammonia. So we cracking ammonia to use it as a catalyst to break down the hydrogen and oxygen to create the electricity eventually. So we have conducted the demonstration with the 10 billion won investment annually. And also by July next year, we target to implement the pilot facilities for ammonia injection to extract the hydrogen with the 99.7% purity for power sourcing. And with that electricity, we can also use it for propeller to analyze it loading. We want to complete that project by July next year. For fuel cell in this regard, I'll talk about that. So in Hyundai, they developed some fuel cells, especially for commercial heavy-duty trucks. And then we tried the conversion for shipment, maritime usage. So there has been many verifications and demonstrations already, but there are other parts they need to be tested further. How we can bring this fuel cell into the marine area by injecting large air, because maritime air is worse than the land air, because maritime air has a lot of the salt concentration in the air. So by sucking up the air from the ocean can be a different situation because this sea water can also damage the filter. Or even worse, it can also damage the membrane and other parts. But because we are given them from the maritime industry, is this a shipment or this military shipment have to check that part. I think so far 6.7% were filtered out that has been patented, but to increase 1.2 or 1 or 2% more for air quality purity, we'll be making efforts. Also, we have to think about cooling system. It's not about cooling down 1 or 2. It's like cooling the temperature of the 1400 Nexon vehicles. How we can do that? This is a totally different game. So we need a different plant for that. How we can implement that in an efficient way by using the seawater. So we have to think about the minimization and optimization with the maritime technology. So for large scale vessel, we have a long-term roadmap. We cannot just sit there doing nothing until then. So Vincent, our company, in collaboration with the Ulsan city, we are doing some projects. Actually, we don't have any legal foundation to support this development, but thanks to the regulatory sentiment, we are conducting this test. So we have identified some issues regarding the safety. All this will be used for laying the legal foundation eventually. So these these bottom two shipments vessels have a smaller size. So it can use the small scale batteries. And this has been one Korean one is for the 16-meter in length. So fuel cells is the main energy source, and the battery is the auxiliary power source. And this is the configuration we're thinking about for development. Can you see we are looking the vessel on the right side? Actually, this is the test and pilot project with the Uber. This is not Uber taxi. So actually, they have a huge market share in the Uber taxi, but they want to conquer the maritime field too. So they want to launch the Uber taxi in seaside. So we've been conducting the demonstration for 1 year, and if we have a good result, this is actually a pilot project in New York and San Francisco for targeting launching in next year. After that, if we have a good result, in align with the other mass transport, we can expand that. And this is purely based on the battery. So when the American harbors have a facility ready, I think it can be expandable. So ABB, Tempus, Powertrain, Motors have been collaborating. They've been well responding to the technologies we are demanding to them. And when it comes to fuel cell, we are working closely with the Hyundai. And when it comes to ship owners, Navigate, we have officially signed project going on. There has been some proposal regarding the 2 tanks with the ammonia cracking system in place. It can be operating for 43 consecutive days with the MEPC system. I feel like the world has been changing so rapidly. By reducing 11%, many people are thinking about solutions. They are racking their brains to come up with the solutions. So far, we need a 2-meter fuel cell with the ammonia cracking system in place with the 20 battery stacks. So I think by doing so, we can reduce 11%. I'm talking about the small and medium-sized vessels. So in collaboration with other vessel owners, we have provided solutions because we have a target to replace the existing vessels. So let me briefly cover the regulation part. I think it's called positive system. So we can do things that is already written, but we cannot do anything that is not mentioned. So even if we come up with some solutions, if it's not covered in legal framework, it's illegal. So we are currently in the process of fine-tuning the proper legal framework. Also, with the support of the Ulsan city, we are thinking about all the possibilities, and the legal action will be followed. And this is our team members. We are from the great logic company with our own ambition. Thank you very much. Thank you for the great presentation. That will be the end of the second session, hydrogen mobility. We will have a take a moment to reorganize the venue. And panelists, please be ready for the discussion. I understand this is getting close to lunch hour. I'm sorry for that. But we have to keep up with our schedule. So we will have a panel discussion by 12:50. Please come to the podium.
Dr. Afkare Adnanes, ABB Marine and Ports Director. He couldn't make it to Korea because of COVID-19, but he will join us virtually. So please welcome him with a big round of applause.
Good afternoon. I am representing ABB Marine and Ports Division, and my presentation today will therefore be what we are doing in the marine business with relation to hydrogen, what we are doing today, and also share some thoughts about how we see the future for hydrogen in shipping. And the shipping industry today is entering into a transition or a transformation, which is, in my view, the biggest transformation since the introduction of or invention of diesel engines back in the 1800 something. And that is due to the environmental requirements and the IMO's targets, International Maritime Organization targets, to reduce carbon emission by 40% in 2030 and in 2050 by 70%, using 2008 as the reference level. And considering that ships that are being designed and built today will be in operations for many years to come, maybe 20 years or maybe more, it is an urgency to start to do this transition already now. And we believe that hydrogen and other fuels which are derived by hydrogen will be an important part of this transformation. A few words about ABB. I will not say too much, but for those of you who do not know the company, we are a technology company. We are focusing our business in electrification, in motion, process automation, and robotics. We are a multinational or a global company operating in all three regions as we define them by Europe and Americas and AMEA, Africa, Middle East, and Asia. And we are about equal size in all these three regions. As a company, we have also set our targets for our own sustainability, and we have declared that we shall be carbon neutral in our own operations by 2030. And since we are very much into this power transmission and power transformation in the industry, there's a lot of electrical energy which is going through our systems. So our impact on the greenhouse gas emission reduction will be even bigger when we're considering what we can do for our customers. So we have also set a target for 100 million ton production annually for our customers by 2030 for the systems that we are delivering from 2021 until 2030. As a company, we have this vision and philosophy that we should be a global company, but also act locally. And ABB has been in Korea for more than 50 years. We have several locations and factories. We have the full value chain from sales to production to service in our sister company in Korea. We have more than 500 employees in our operations in Korea. I will also show this reference project that we have now. This is the first domestic zero-emission ferry, and we were honored to be awarded a contract for delivery of the electrical power and propulsion solution for this vessel. It is not fueled by hydrogen. This is a fully electrical vessel with battery electric propulsion and shore charging for doing the transportation of people outside of Busan port. It is now under construction at Haemin shipyard in Korea. So what we are doing in this business, marine business, the core of what we are doing is electric propulsion. So using electricity generated by a prime mover or an energy source to make the propulsion of the system by using electrical motors and to drive the propellers. So that is the core of what we are doing. Diesel electric propulsion was already pioneered more than 100 years ago, so it is not a new technology by itself, but it has gone through quite rapid and substantial technology development since the start, of course. We have also made a transition from diesel electric systems, which became very popular during the 80s and 90s due to the higher efficiency and fuel consumption, lower fuel consumption, but also the operational performance and the comfort of electric propulsion compared to mechanical propulsion. So we have gone through diesel electric, we have gone through gas electric using LNG as fuel. We see fully electric propulsion vessels now with batteries and shore charging. And now it is the time for us to enter into a new area where we are using carbon neutral fuel as a new energy source for these kind of systems. And in electric propulsion system, we have an electrical backbone or infrastructure in the vessel where we are connecting the energy sources to the electrical power grid and then connecting the ship loads and the propulsion loads to the same grid and managing to optimize the power generation as much as possible in the system. And with this electrical infrastructure, it is much easier to plug in new and different energy sources as long as they can produce electricity. It is more or less to plug them into the electrical grid, and then you can start operating with the same installation as was there from the original. So what we say is that if you want to make a future-proof concept where new technologies and new energy sources are being developed as we go along, and utilize those for the future operations, then an electric infrastructure is a future-proof concept. There are two types of such electrical system. The conventional system is this, what we see on the top there, that is the alternating current solution. But we also have introduced a DC grid solution where we are distributing the electrical power by using direct current instead of alternating current. And that has certain advantages. So First of all, it is more easy to connect to the different energy sources, and each energy source can be optimized by itself and not as a complete system, which gives better performance and better efficiency of each of the source and also for the consumers. There are less steps in the power conversion, so there are less losses and better efficiency. And with a DC grid, it is much faster time to recover from a faulty situation, and much more opportunities also to make a robust, reliable system by using reconfiguration of the system, which is one of those, I would say, pillars and platforms that can enable also autonomous vessels in the future. So features, if we are using combustion engines, we can optimize each combustion engine by using variable speed in a DC grid. The power is distributed on DC, as I said, and it is easy to integrate alternative and different power sources. This is the rules and the roadmaps and regulations towards these targets for IMO 2050. I will not go too much in detail to this one. I will only highlight these two milestones here now. 2030, 40% CO2 reduction, or intensity reduction, and in 2050, 70% carbon intensity reduction compared to 2008. And we see already that IMO has, and countries and regions, they have also already started to implement stepwise rules on this path. Okay, coming to hydrogen. So hydrogen, as we see it, will be one of the fuels that will enable this carbon reduction. And also out from hydrogen, there are different ways to use it. We can use it directly in the fuel cell, for example, or we can use fuels which are derived by hydrogen. That could be ammonia, it could be synthetic diesel, synthetic methanol, or synthetic methane. That could be energy carriers for the future ship systems. If we look at the use of the different fuels, this is a conclusion or a view from a large industrial study that was made in Europe, Hydrogen Europe, with several participants. It is a little bit smaller, so you can't probably see the text there, but I can explain. The blue here on the left side, that represents the market as is being seen for compressed hydrogen. The middle sector here, the white with the green dots here, those represents liquid hydrogen market. And when you come to the larger vessels and the longer distances of traveling, then neither hydrogen or liquid hydrogen was found kind of feasible to cover the needs for those. So there this group concluded that a liquid fuel and green ammonia would be the major energy carrier in that area. So we can see on the left side that is very much related to coastal vessels, short distance shipping, inland waterways. The middle sector, that is more regional type of vessels operating between shorter distances and shorter port-to-port voyages, while the deep sea shipping with the tankers and bulkers and LNG tankers and so on are on the right side, that probably will need liquid fuel in the future unless something revolutionary happens during the next coming years. So we see different usages and different technologies for the different vessel types, and that is also one message, that we don't see one solution that fits all. There will be a variety of solutions to be deployed into this industry. For electric propulsion and energy storage, we have seen a development where the first movers are the small coastal vessels, short distance shipping and inland waterways. They have been the fastest movers and coming first to the market to use energy storage systems, batteries and so on. while we then see a gradual adaptation to other segments like the more coastal vessels and this deep sea vessels coming also into the play. So for energy storage, we see that now all over the spectrum of vessel types. And we believe that similar development we will also see on use of fuel cells, that we will first see it on a very local trade and local routes, while it become into other sectors as we go along. So coming into what we are doing now and what we have been involved in fuel cells in the marine. So these are the projects that we have been running and we are running today. The two first on the left side, and those are demonstrator units. So that was more to demonstrate that the technology using hydrogen and fuel cells are feasible for marine applications. They are not a central part of the electric propulsion system, it's just demonstrating the technology. Then we have two European Union supported projects, Miranda and Flagships. They are ongoing, where also it is a demonstration and prototyping installation on the vessel for one research vessel, Aranda, and for one river transportation vessel in France. The most recent project, that is a commercial project. It is not funded by European Union or other research fundings. It is a pure commercial project. The vessel type and the owner cannot be disclosed. That is confidential. It is an ongoing project, and there we are integrating a 3 megawatt fuel cell package consisting of several smaller fuel cells into the DC grid and electric propulsion for this vessel. So when what we are doing in terms of the fuel cell itself, ABB, we are not producing the fuel cells. We are working together with other suppliers of fuel cells. So we have been working with several suppliers in Europe and in North America. So these are typically smaller fuel cells up to 100, 300 kilowatt. So we call them low power generation units. And those are the units that we have been working with in the pilot projects that I showed in the last slide. We have also started a joint development between ABB and Ballard in the US, where the target is to develop a high power unit from 1 megawatt to 3 megawatt in one unit consisting of fuel cell modules and a modular construction, so that we can standardize the design 1, 2, or 3 megawatt unit for the higher power vessels that we foresee will come in the years to come. And this shows the integration of fuel cells and batteries into the system. So here are the fuel cells, the low power generation unit fuel cells, as many as needed to provide the power for the propulsion. Fuel cells and batteries, they are two sides of the same coin. If you have fuel cells, you should also have batteries also to stabilize the load and give the dynamic performance that the vessel needs. We have the DC distribution system here, and then the electrical package here, which is driving the motors for the propulsion. And this has also been equipped with a shore charging system. So this is the concept that we have developed for a coastal bulk carrier in a concept study that has been carried out in Norway, but can easily be adapted to any other region as well. So that was actually my last slide in this one. So I just have to end by saying kamsahamnida and thank you very much.
네, 제가 알기로는
Well, to my knowledge, ABB is based on Swiss, right? I think it's very interesting for you because it's a shipment connected. He mentioned the IMO, International Maritime Organization. So they've been showing the effort to reduce the carbon dioxide emissions. Thank you very much for the insightful presentation. I hope we can ask his opinions in the panel discussion. Next. Taking this opportunity, I'd like to express my gratitude for the speaker joining us from the internet. Next, I'd like to invite the third speaker. I know we are behind the schedule. We will hurry up. The third speaker is Yang Jae-chun from Ulsan Fuel Cell Power. He's the president of the R&D Center. He's going to talk about the hydrogen fuel cell development in Ulsan. Please welcome me with a big round of applause.
안녕하십니까. 저는 두산 퓨얼셀 파워의 양재춘입니다. 그래서 오늘 말씀드릴 내용은 저희 두산그룹에서 연료전지에 어떤 사업들을 하고 있고, 특히 이제 저희들 퓨얼셀 파워 비즈니스 유닛에서 어떤 개발을 하고 있는지 위주로 설명드리겠습니다. 그래서 우선 이런 내용들로 설명드릴 거고요.
Okay, so let me skip due to time constraint. And Tucson is working on many fuel cell businesses, starting from power generation, buildings, and residential, and TMI, drone. So we engage in many different types of fuel cell business. So let me briefly explain our company, Tucson Group. And you can see companies and affiliates. And there are slight changes in this slide. And you can see among the companies you can see here. And left-hand side, you can see Tucson Fuel Cell Power, which is working on buildings. And also Tucson Fuel Cell has a power generation and vessel, PAFC and SOFC. And also Tucson Mobility Innovation has a drone business. And also there is a Fuel Cell America phosphate. It's a clear etching. So they take over this business from us, and they actually started this phosphate area. So they run this business in the US. So basically 4 companies engage in a fuel cell businesses. And so for housings and buildings and power generation vessels, drones, and mobilities. So these companies has in Ulsan there is a Tucson fuel cell, and here we have a plant that makes a power generation. And also we have a PEM in Hwasong. So mostly they're making for buildings and drones and residential and PMI. And actually we do support PMI as well. So PMI businesses in Hwasong. And R&D center is in Suji. So R&D center is in Suji. Like I said just now, and Fuel Cell America is located in Connecticut. So then I will just briefly introduce we started as a venture company. We started from 2001, And so we developed MEA and stack and core components for stack and MEA. And we initially developed and commercialized 1 kilowatt residential, and then we move on to buildings, 10 kilowatt building products. And you can see our plants. We have a dedicated production line here. We also control quality. And this is the product that we make. 1 kilowatt for residential, and 5 kilowatt and 10 kilowatt for building. So, residential, this is LNG, LPG. So since 2006, we've manufactured roughly 2,300 units. So they are installed and operated since 2006. And recently, we also are developing a hydrogen system, and it's a government-led policy project. And this is ongoing in Ulsan and Samcheok. So let me briefly explain the application areas for buildings. We have a large apartment complex, hospitals, and also townhouses. Recently, we provide 10 kilo unit. And so you can see the example, not just electricity, also PEM emits heat as well. So we can also take advantage of heat, and hotel, sauna, and other accommodation areas. We can actually retrieve this heat. The electricity efficiency is about 37%. Combining with the heating efficiency, it's about 98% efficiency. And recently started to work together with Ceres Power to develop SOFC. And so we are actually entering into this area for buildings as well. I will explain this later a little bit more. And this is a Tucson fuel cell. And we have a phosphate business, and initially it was IFC. So IFC is the company that initiated a phosphate, and so Tucson took over in 2014. This is the data from 2019. So the accumulated power is 300 megawatt. So there is some more update. So we see results. So let me briefly explain the system. And so power is 440 kilowatt. Electrical output is 440 kilowatt. So the temperature is higher than PEM. So it emits heat. So if we utilize heat as well, then the efficiency is up to 98%. In the case of phosphate, durability has been proven. So it's a proven system. And also durability is up to 60,000, 80,000 hours. It uses a LNG and also hydrogen. So So the electrical output is same, but so LNG has higher efficiency. So if the electrical efficiency is higher, then other efficiency is low. So we do have a system which is efficient up to 98%. And these are some of the examples. So we have a 46 megawatt overseas, and on Korea we have a 210 megawatt installed. So for large buildings and power generation, this is being used. And Tucson's DMI. So it's a company that handles drone, DMI. So we used to use a battery, and it takes half an hour, less than half an hour for charging, and it can only run for half an hour as well. But if we use hydrogen, then we can use more than 2 hours. So extended operation time. And also, besides this model, recently TMI introduced many more models. So the power output is 3 kilowatt up to 9 kilowatt. It's a power pack. It has a fuel cell and hydrogen supply. So it is equipped with a hydrogen tank. If it's a 3 kilowatt and 5 kilowatt, they're using air-cooled. But if it's a 10 kilowatt, it needs a cooling system. And so the government project is underway to develop 15 kilowatt power pack. And so these drones can be used for inspecting infrastructures, logistics, and delivery as well. So there is a great potential for market expansion. So I will briefly explain the technologies that is used for fuel cell for buildings. So building fuel cell. So it is installed in residential areas, and they emit electricity and heat. And also it can use LPG as a fuel source, or in the future we can consider using green energy source, including hydrogen. So if we use LNG, then it generates hydrogen, and also there's a stack that generates electricity, and there are BOPs that need to control this area. So what we do is so we are studying the reformations, and also how to make stacks and how to make a efficient stack is something that we are studying. Also low-cost stack. So to run this fuel cell system, so we need to diagnose the devices to extend the life. We call this RMS. So we remotely monitor and diagnose potential or future default and prevent. And also we co-develop a core components and BOPs and determine pricing of those components as well. So this slide shows a system development process. So we call this model-based design. So we apply MBD process a lot. So we put together a model, and rather than making a product directly and going through trial and errors, it's better to go through a simulation phase so that we can shorten the development time. So system component technologies, core technologies, and validate, verify the designs, and also diagnose a potential fault. And these are a core part of our system. So the fuel cell for buildings, in the case of Japan, it's 10 years. In Korea, it's about 5 years. So the requirement is 5 years for Korea and 10 years in Japan to verify this life. We monitor the data from the field and to verify the durability. So not just LNG, but also hydrogen PEM. It is important to validate durability. It is important project as well. So for buildings, we have a reformer. So reformer is the one to create hydrogen and remove the impurities. So Japanese reformers, you can see the examples of Japanese reformers. It's a flat type or tube nut type. Mostly, there are two types of reformers for MF1. This model is mostly used for buildings in Japan, but in our case, so how to make this reformer well, since its temperature is high, so we have to think about materials and how to design well, and also how to guarantee the durability of catalyst, and how to make well in production phase. These are things that we have to understand and study. So next is the stack area, and stack design looks like this. So for buildings, we are supposed to have more than 100 cells, MEA, GBL, how to design them is really important. So currently we are using graphite-based separator. We also consider metal-based separator as well, because it can offer a cost reduction. So we are running R&D to come up with a cost-efficient separator. So simulation, we go through simulations and evaluations. So efficiency is important. So next is SFC, SOFC. So it could be metal plate support, anoid plate support, or ceramic flat tube support. So there are 3 different types. So the one we are working on with Celesta is a metal plate support type, SOFC. So if we use metal plate support, so the operation temperature can be lowered. And also the operation time or uptime is less than 5 hours. And thermal cycle and emergency stop, it has many strengths in these areas. So we are developing SOFC, metal plate support-based SOFC for buildings. And this is what we unveiled. This is the design for 10 kilowatt SOFC. So it's about 53.8%. So we try to raise it to up to 60%. From 2024, and Tucson fuel cell will be able to produce SOFC in Korea, then we'll be able to drive down cost a lot. And also we can have a higher efficiency SOFC. So we will have a market where the electricity generated out of buildings can be sold. So we developed this as OFC because it has high efficiency. So we just completed the first phase of development. So the next step is to consider how to boost efficiency and lower costs at the same time. Since not much time is left, so let me briefly share the future plans. So LNG and LPG, we are using fossil fuels like LNG and LPG these days. We'll migrate to green energy, hydrogen, and green society. And I believe that hydrogen is a crucial element in that society. Then how to make this hydrogen and how to utilize hydrogen are some of the topics that we try to study. And also each side generate hydrogen, but in the future we may have hub so that we can have a network connecting it hub, and also this can be supplied to fuel cell system. So we are developing hydrogen system to support the future. Also, we are participating in a pilot city project run by the Korean government. So this project is ongoing in Samcheok, 1 kilo, 5 kilo hydrogen PEM system, and we are supplying them. And also we co-developed a 25 and 100 kilowatt along with Ulsan in the past. So based on this experience, we try to prepare for the future hydrogen society. This is the end of my presentation. Thank you.
네, 고맙습니다.
Thank you very much. Ulsan is basically very strong when it comes to supplying the residential energy, and also high efficiency energy. I think they've been combining the joint forces with 7 other companies. I can see how much they are focusing on the development. Thank you very much for the great presentation. Please give him a big round of applause. Next.
Next is a special session. So we're here about the government policies. Chang Young Kim from Department of Foreign Investment and Trade in Ulsan Metropolitan City will give us a lecture on seminar for investment of small but strong business in Ulsan. Please welcome him with a big round of applause.
예, 반갑습니다.
Thank you very much for the introduction. I'm Kim Sang-yeon from Ulsan City. I'm very honored to be here with a special session to introduce Ulsan. Taking this opportunity, I did really my best to give you the great information regarding city. Please enjoy my presentation. First, I'd like to cover the status of Ulsan and the investment environment and what kind of incentive Ulsan City has provided to you. So I want to show how attractive Ulsan is for the investment. First, let me cover Ulsan City introduction. It was established in 1962 as a special industrial area. This is the beginning of the industrial development. Before it was like a small fishing village. and the population reaches over 1.15 million, and GIP per capita is number 1 in Korea. If we take a look at the industrial mix, 61.8% goes to manufacturing, 38% goes to service industry. This is a very unique. If you take a look at other counties, the areas, it's the opposite. They are focusing more service and less on manufacturing. But given our unique position, we can say that Ulsan is industrial city. And also, we are number 3 in nationwide when it comes to export amount with a $56.1 billion. It was a slight drop, but we rebounded again because of the increase in the sales of automobiles and shipbuilding industries. And our major industries covers petrochemicals, and automobile industry and the shipbuilding industries. Actually, number 1 in automobile is the Gyeonggi, and when it comes to shipbuilding, there's another area is number 1, but we are quite close number 2. So these 3 pillars are the major industries in Ulsan because they covered all full spectrum of the production. It means that for SMEs, this is a quite attractive area to supply to the larger scale OEM companies. Let me cover the transport logistic condition. This is a Gyeongbuk highway, and you can see the green line. That is also another highway, and there's another highway connecting Pohang and Ulsan. And this area you can reach within 1 hour. If you take a look at the outside expressway, these are connected to the seaside. And thanks to government support, we are in design stage. Once we complete this highway, if you build a factory in Ulsan, you have a very easy access to nationwide locations. Next, let me cover the industry complex. We have 2 major government-sponsored funded industrial complex and 27 regular industry complexes. Some are already completed, and they are in the process of division to the smaller companies. This highway is actually only 5 minutes away from here, and 50% are only assigned to the other companies, so 50% off for grip, so you can apply for it. And this area, it's called KCC Industrial Complex with the access to the Gyeongbuk Highway. KCC, I think 90% are already completed for subdivision, so 10% are available. And there's a number 39 highway. There's an energy combining industrial complex. Still, 60% are available if you are interested. And the subdivision price are available if you're interested after my presentation. And then we have some industrial complex in idea. There will be high-tech Valley General Industrial Complex. Also, the another one we are planning to establish the KTX Ulsan Metropolitan Area Industrial Complex area. And we already have a first free economic zone, so we want to establish second one too. And along the seaside, we also have a high-tech complex is ready for launch. And besides, we have many projects going on. I will come back to it later. In Ulsan, why it's attractive for businesses. There are so many companies, Hyundai, Hyundai Mobis, Hyundai Heavy Industries, Lotte Refining, Lotte Chemicals, Samsung SDI, Hyosung, Hyosung High Tech Materials, SK Energy, SK Gas are all located in Ulsan. And we have a lot of the FDI too, as oil-based KNC, Total, all these big hands, big players are also in Ulsan. And also, for the last 10 years, we have expanded our R&D capabilities. Within the UNISIC, we have big R&D centers. Within the UNISIT, they have another related academic, corporate, research, collaboration research center. Why is it nice to have them in Ulsan? The research facilities can be used by small companies with a low cost. If you go for our homepage, you will check out what kind of facilities and equipment is available. You can apply for the uses of these equipment and facilities. Next slide, I'd like to briefly introduce our projects. I will cover it in briefly. You can take a taste of the Ulsan's major projects. I named it 9 Growth Bridge for the Future of Ulsan. 5 Energy. This is a new growth engine part. And the 4th, Happiness Growth Bridge. This is a related infrastructure establishment. First, floating offshore wind power generation. This is about 6 gigawatt power generation floating wind facility, unlike the stationary one, that is conventional one. And this is a complex 6 gigawatt worth of the size. So 1 megawatt itself is already big size. And then we have a 6 gigawatt. It means we have a big power generation coming from the wind renewable energy. That will create the new jobs and that will reduce we can also reduce the carbon dioxide more than 200 million tons. So that involves a lot of the players. So we will establish 600 units of the wind facility. So it means that we will involve a lot of the companies, and we want to make sure that we use the local companies and local technologies. So I will believe that there will be a great opportunity for Korean companies. Next, hydrogen economy. I'm sure it's a very familiar concept to you. Hyundai in Ulsan is for the first time in the world to produce the hydrogen electronic vehicle. By 2030, we will serve as a leading player in hydrogen economy. By then, we aim to provide 670,000 hydrogen vehicles with a lot more charging stations. Still, we have 9 charging stations. This is the largest number in Korea. I'm not sure if this is the exact number, but out of the hydrogen vehicles, half of them actually was sold in Ulsan. And also hydrogen pipeline, we plan to establish 200 kilometer pipeline. So we have a byproduct hydrogen that can be used for cheap price. 1 kilogram for hydrogen is 7,000 won. That is 60% of the gasoline for the same distance. So that's why it's a very popular option as an energy source. Next, we want to aim as a Northeast Asia oil gas hub. So we aim to we are in the process establish 2,500 size of the LPG storage facility. Actually, last week we have a very similar. We have an in-depth conference last week, and also nuclear power decommissioning business. In Ulju, I told you there's another energy combined industry complex. We plan to establish world-class large-scale nuclear power decommissioning industry complex. Already 3 companies involved in the decommissioning technology have been joined the complex. Given we have a lot of MOU ongoing, I believe more companies will join this complex. Next, we have Ulsan Economic Free Zone. Despite we have a very high position as an industrial city, we didn't have a proper economic free zone, but finally we got the permission from the central government to establish the economic free zone, and we set 5th special zone and complex, mainly focusing on replacement of nuclear power and the high hydrogen economy. And there is a 5th special zone. This means that they will get the special exemption that is not available in other areas. And there are many talking about the secondary fuel cell. And also, there's another area that specializes in the technology regarding the ESCC and the carbon neutrality. I believe they have many ongoing demonstration business. And also hydrogen mobility special zone. There are many regulations regarding the hydrogen. For example, LNG charging station. A hydrogen charging station cannot next to LPG gas charging station. This kind of regulations are daunting. But in Ulsan, they have an exemption. They can try out their new ideas. And also we have a genome service deregulation complex in UNIST, Korea's MIT. They discover on Earth 10,000 people's DNA analysis. Chronomics, one company, as we studied from Ulsan University, the professor started this startup, and they are very promising. So when it comes to DNA analysis, they will accumulate more data, and they will eventually provide customized service to others. So I believe that they will set them apart from other area. Lastly, energy-related special zone that will include the decommissioning of the nuclear power plant. So regarding the industrial complex, let me talk about money. What is the price of the subdivision? So this is a very convenient located. The subdivision price is the 1 million won per square meter. Normally that's twice more expensive, so this price is very competitive. It's because thanks to the city's support, we don't charge you for the margins. This is like almost giving you free, except the raw cost. And there's another area complex that is only 5 minutes away from this train station that's even cheaper. Also, the Ulsan Sea is directly involved in creating, and 50% are available. And next is energy combined industry index is actually combined by the Ulchu-gun, Ulchu County, and they aim to attract the general mechanics, metals and manufacturing and research facilities. And Janghyun City sophisticated industry complex. This is a very unique given that it's a industry industry complex within the city. They aim to attract the green car energy part material. But given that it's a very good location, it's slightly more expensive than the other industry complex subdivision. It has not been completed yet. In 2025, that will be completed. And the area where we are, this is called KTX Ulsan Metropolitan Combination Special Zone. And the convention center we are now staying is part of it. And Lotte is in charge of the construction. And KTX train station is very close. The first stage already completed, and there are very few availability. So second stage will be open. Given that it's very close to train station, it's pretty expensive. I believe the bidding price will be 6 to 9 million won per square meter. Next, Ulsan Free Economic Zone, Free Trade Zone. This area is owned by the local government and the central government 100%. So you don't have to buy it. You just have a lease. So Ministry of the Commerce and Ulsan City, they have a joint ownership by 7-3. And then we have a standard factory that's like an apartment style factory, and the lease will be 600,000 won for 1,000 square meter 평. I think it's almost like a free of charge. This very competitive price. And Gangdong tourism industry within this complex, Lotte Construction is established in Gangdong Resort, Ulsan Safety Experience Exhibition, Keys Auto Park Ulsan will be also established. And Ulsan CC, the golf course, also will be established. Lastly, let me cover the financial incentive. First, we have a program to support the Korean companies who went to overseas. By providing incentive, we want to bring them back to local area. So by moving their factories from overseas to Korea, you will get the financial incentive. The other support is to bring your facility or factory from Seoul metropolitan area to local area. And if your investment is more than 1 billion won, we also provide the financial incentive accordingly. So they have a set number for that with a ratio fixed. The maximum will be around 10 billion won. What about the companies moving from non-Seoul metropolitan area to Ulsan? And they will get the different financial incentive. They have a different condition to criteria to meet regarding the number of employees and the investment amount, and they have to keep their business intact. Because the goal is to create a new investment. So there's a difference between these two programs. So for the new investment, we provide the land too, but when it comes to the type 2 relocation, we only provide a different incentive. So these two big incentive programs are applied to all of the Korea. So this is not unique in Ulsan. And we have the Ulsan City only financial incentive. If we take a look at the criteria to meet, if you have employ more than 20 people, if you have a more than 1 billion won investment, if you have a land acquired, so depending on your investment amount, they will get the ratio, fixed ratio reimbursement or financial incentive. Let's say for large scale investment business, if you have a more than 50 billion won and more, 20% of your investment amount will be given back to you. And relatively, for the small companies, we have a program to specially support the small yet strong companies with the technology. So the criteria is they have to hire 10 and more on a regular basis. If you're not, they have other conditions to meet for be entitled for the financial incentives. Lastly, this is about the exemption of the local tax. When you join the industrial complex, acquisition tax will be exempt by 70%, property tax by 75% for 5 years. And if you have a agricultural land you join, then you will have a 40% exemption of the acquisition tax. Please refer to the slide for further information. And if you have any further questions, please contact us. We are very happy to help you with the further information. Thank you very much. I can see Ulsan, why Ulsan is number 1. And he has shown how attractive Ulsan is for investment. Please give him a big round of applause. I think we're 20% delayed. I think we can go ahead without break. Next, I'd like to invite the next speaker in video clip. He's from H2WORLD. He will talk about his company and the leadership in the world. Please understand this is a special occasion because of the Corona situation.
My name is Joseph Lennox, and I'm the Business Development Director for Asia for Sarah's Power. Typically, I'm located in Seoul, South Korea, and so I should be there in person with you today. But unfortunately, with the nature of my job, I'm on the road a lot, and so I'm going to have to make this recording from a hotel. But thank you very much to the organizer of this event for inviting us and for asking us to participate. It's an honor to be here, and it's an honor to speak with the audience. So without further ado, I'll jump into my presentation. Okay. Well, so I was asked to speak today a little bit about the Ceres Power story in Korea. We've had a long-standing history in Korea. My own story with Ceres Power begins in 2015. We've been quite active here on the ground for quite some time. And, you know, that's a point that I'd like to emphasize, that Korea has always been a very special and strategic market for us, even before some of the most recent events that we've seen around the Green New Deal. Korea has always been an attractive place for fuel cell and new technology companies related to energy. And that's greatly because of the kind of forward thinkingness that we've seen from the government here, and a lot of the policies that have been able to be agnostic of domestic politics while promoting new ways of doing energy. So today's presentation is a bit about us, our story, our vision, and also kind of the approach that we've taken to the Korean market and why, and a bit more about what's next and what we envision around the future. So first of all, so Ceres Power, if you don't know us, we're a technology licensing company, which is unique, with a special background related to solid oxide fuel cells and solid oxide electrolysis. So we define ourselves as an electrochemical technology company. And because we are a licensing company, we are not meant to create products into the market, but we enable partners around the world to develop products around our core technology, a bit like an arms holding or you know, Intel inside. We believe that our core technology are going to be the gateway into lots of new products and applications into the market on both the power generation side of our business, which we have a 20-year history of, and also on the hydrogen generation or electrolysis side of our business, which is relatively just getting started, which started back as an R&D project in 2019 and is now rapidly going through validation, including a megawatt scale demonstrator that's meant to go live sometime next year. But because of that, that means that we're a company that's very focused on improving our technology, ensuring that our partners are always on the cutting edge with the most competitive options. And, you know, it means that we go around the world creating partnerships with the partners that we think are going to be the market leaders in the market, and who we think best serve the types of joint success that we need to create as a licensing business. So this is kind of a why are we here today? We very much see the climate crisis as something that is rising in urgency, and it's no longer a problem of individual nation states, but something that is very much seen now as an 8 billion person problem. The urgency around combating climate change has only grown around kind of some of the transitions that we've seen in COVID. And recently we've seen a lot of activities amongst governments and organizations announcing net zero targets and ambitions around improving how we do energy around the world. And our flexible licensing model is something that can enable these types of organizations to get caught up if they're behind, because we offer reference designs and lots of different paths to businesses to have access to very competitive technology, but also with a chance to be flexible enough to make it into their own. You know, in recent years, we've seen improvements in regulations that are promoting a new approach to energy. That has inspired already, we're seeing industry beginning to react, including a recent 200 plus hydrogen-related projects around the world. And last year, there's been a surge in green investments looking to support this energy transition in the world's future. So as I mentioned, as a licensing business, we grow our business through partnership. These are some examples of some of our major partners to date. Doosan, I'll talk a little bit later about, because I have some more slides that goes more in depth. but we also have strategic partnerships with Bosch, who's also a strategic investor in Ceres Power and has pledged to begin a 200 megawatt plus factory footprint, which they're currently scaling as we speak, that should go live around 2024. Wed-Fri, who is also a strategic investor in Ceres, is working on 30 kilowatt range extenders for electric buses, which they're also working on 30 kilowatt stationary applications in China as well. And then, you know, those are some examples of our kind of manufacturing OEM partners, but we also have other strategic relationships, such as the one that we have with AVL. You may be familiar with AVL as a major engineering service company that has a long history in fuel cells and green technologies as well. We have a close collaboration with AVL, which allows us to further improve our business and improve our offerings to our partners. I believe there's actually even a speaker at this event that's coming from AVL. His name's Joseph, not to add confusion. We share the same name, and we also share a very important partnership. So this slide here, it's a bit busy. I know there's a lot of information that's been captured in one slide, but I wanted to pull this up just to kind of show you the rapid fashion in which we are onboarding new partners and in which partners are expanding the offerings that they're bringing to the market based off of the Ceres technology. In some ways, I think new partnerships being announced are a great testament to validation of the technology. I think expansion of those partnerships is even bigger testament to that. And you can see that, let's use Doosan, for example. We started our first public relationship with Doosan, which you can imagine took a bit of time to create, even coming up to there in 2019. That was with the joint development of a 10 kilowatt CHP system, which just this year has come to completion, and Doosan has announced will go into soft launch as of next year. And that was the beginning of our relationship in Korea. And you'll see that just last year in November, that early relationship with Doosan Corporate has now expanded to a much larger and deeper partnership with Doosan Fuel Cell and Doosan Corporate, which includes not only the collaboration on system developments around a utility scale system, but also things like building manufacturing capacity of our core technology, similar to what Bosch has announced. And our partners in Korea are targeting a factory to go live around the year 2024 with an initial scale of 50 megawatts, something that we're working on together very closely. Doosan has since announced several MOUs related to the marine industry, including an MOU with the shipbuilder subsidiary of Hyundai Heavy Industries, in which they're integrating our SFC core technology into auxiliary power demonstrators for ships. And they're doing the same in Singapore with their partner Navigates, which was another MOU that came in kind of early 2020 or late 2020. So when we say that we are a technology provider and an enabler, what we mean is that our core technology is our cell chemistry, which we have put into multiple stack platforms, which our partners then utilize or leverage to create systems around. So a good example is Miura in Japan has created a sub 5 kilowatt CHP system that is already commercialized and being sold commercially in the Japanese market. Bosch has created a 10 kilowatts system that can be run in either electricity only under high efficiencies or CHP mode. Doosan, I just told you about the 10 kilowatt system that's designed for commercial buildings. I think both of those applications are essentially targeting things like data centers, distributed power, industrial sites, apartment complexes, and so on. And then we have Wed-Fri with their 30 kilowatt range extender that started as a mobility application that is now expanded and leveraged as a module to serve for stationary applications in China as well. This system that we have a picture of at the bottom is a picture of the demonstrator that we're working on for solid oxide electrolysis that's meant to go live sometime next year. And I look forward to introducing more updates to the market on that later. So in order to be a technology licensing company, you have to have something that's unique that's difficult to be copied and that's well protected. And that's essentially kind of the core asset of our business is our technology and our know-how. And I think you'll hear from our partners at AVL a bit more about PEM versus SOFC. If you don't know already, you know, SOFC has a reputation for being highly efficient and fuel flexible, but you're stuck with things like stationary applications because typically ceramic supported technologies struggle with thermal shock. They struggle with vibrations that can essentially damage that technology. PEMs are lower in efficiency, much lower, maybe 30–40%, depending on the system architecture in which they're integrated in. And they're reliant on very, very high purities of hydrogen, which offers advantages and disadvantages. But it's relatively mature technology with high power density that makes it robust enough and compact enough to be put on mobility applications. And so this is seen as kind of trade-offs on different ends of the perspective. The Ceres technology is a metal-supported, metal-based technology in which, you know, what we do well is we're able to print very, very thin layers of active ceramic chemistry onto perforated sheets of steel, which results in a metal-supported cell, which the materials are predominantly made of steel. And that has enabled us to operate at a much lower temperature than traditional SOFC. We're operating at around 600 degrees instead of around 1,000 degrees of traditional SOFC. And so we really see ourselves as the next generation of solid oxide fuel cell technologies operating at a much lower temperature, which reduces the cost of some of the materials and also the different processes that we use to create our cells. And it also happens to result in the most robust solid oxide fuel cell technology in the world, which has opened us up to be one of the few solid oxide technologies available to be leveraged and utilized in mobility applications, such as the range extender project that we have on electric buses in China, and also marine applications like our partners at Doosan, or the government program that we're working on, 2 feasibility programs for big shipping applications and also cruise ships in the UK. So, you know, the reason why I've probably been invited to speak today at this conference is that we have a very special relationship with Korea. We've been here active on the market for quite some time. Starting back in 2015 was when I came on board. And that attraction that led us to Korea was based off of the Lee Myung-bak administration's Million Green Home project, which made this a very interesting CHP market. That was a policy that was continued and eventually grew to Korea, essentially doubling down under the Moon administration, under this Korea's Green New Deal, and the hydrogen economy strategy and roadmap, which is why we're probably hosting events like this in Ulsan today, which is going to be quite a famous pilot city for a lot of the new hydrogen technologies that are part of that roadmap. But essentially, we worked very hard to identify who was going to be our best partner that was most aligned with our business model. And we're very happy with where we've landed with Doosan so far. We have a very strong and deep-cutting relationship with Doosan, which has enabled us to essentially promise to the market the factory capacity that's meant to go live at sometime in 2024. It's been a relationship that has continued to expand since the early system development program that we started in 2019. That is now expanded to utility scale projects and also integrating our technology into marine applications with the several MOUs that Doosan has announced. And essentially, you know, we still have a lot of room to grow in Korea, but we're very grateful for our partners and for the strategic relationship that we've been able to build with Doosan. And I don't think we could have done that from purely being remote. And I think I'm glad we had the foresight to be here on the ground and actively work and down select who was going to be our best fit for us in the market. This slide here is just to kind of give you an idea of how our operations have evolved in Korea. You know, as I said, we started in 2015. But even back then, we recognized that Korea really deserved its own tailored long-term strategy and long-term commitments in that sense. And it's something that's still expanding. So we needed to have local experts, local assets, local language abilities. And that was really key in building the trust that we need as a licensing business, because our partnerships are very much based off of deep trust and understanding. And there's a lot of work that comes into pre-contracting to make sure that both parties are really aligned. And then it was back in 2020 that we started Ceres Korea, which was our first formal liaison office. And then it was on the back end of that, I would say, additional commitments in the market that we were able to expand further in Korea, including the expansion described as into manufacturing with Doosan. And then it was around July of this year that we've kind of then expanded or evolved that liaison office into a full branch office. And so I'm the kind of, I say, representative of Ceres Power Limited's branch office Korea. And that's helped us continue to kind of build as a platform for how we continue to service Korea as a market and continue to work closely with our partners. And it's been on the kind of success of our continued investment in Korea that we now have exciting announcements, such as the announcement in September, in which Doosan Corporation announced the success of that initial collaboration agreement that began in 2019, and that product will be launching into the market with a soft launch sometime within next year. So, you know, even if I just look at the story and narrative that we have in Korea, we've been able to start with a company that was very focused on smaller residential SoC applications in micro CHP. And we've been able to work with partners like Doosan to expand to multi-kilowatts, tens of kilowatts types of installations that are targeting larger, higher power applications, including utility. And we've also been able to kind of explore new mobility applications, such as some of the marine applications that we're targeting now in places like Korea and other parts of the world, or even in heavy duty trucking, like we have with the electric bus range extender with Wed-Fri in China. And we believe that the next phase or the next chapter of our business is going to be also servicing the power generation side of our business, but also the electrolysis side of our business is really what we see as the new frontier, and something that we already have a lot of interest and activity around. And what's interesting about this is that, you know, you saw a picture of the stack and cell. We are able to leverage the same cell technology and stack platform in two different operation modes, which allows us to have the power generation side of our business and the hydrogen generation side of our business being serviced by the same core technologies. That means the same cell stack, IP portfolio, manufacturing processes, supply chain are going to be servicing both Ceres Power and Ceres Hydrogen as we continue to kind of grow and mature that side of our business. And in Korea and around the world, we have a lot of opportunities still, in addition to the power generation side of our business, which has been related to, you know, when we started back in 2001 as a fuel cell company. But now we've evolved to a more electrochemical company that is focused on green chemicals and enabling the new hydrogen economy in a different way, from a renewable energy based hydrogen supply, which we believe is going to enable a huge new chapter within our business as it relates to green chemicals, feedstocks, things like gas blending for industrial processes. There's a lot of new opportunities essentially that we're going to be able to open up with this new side of our business. And so, you know, what do we have left to do? We have strong representation on the power generation side already, but that's something that we can continue to grow. And we see the marine sector, utility generation, and solid oxide electrolysis as major new growth markets for us as a business, and something that we'll continue to explore in different parts of Asia and Korea. You know, we're very grateful for the reception that we've received from all the help from places like MOTI. We've gotten a lot of support from the British Embassy here in Korea, And most of all, we're very grateful for all the support that we get from our partners at Doosan. And we hope to continue to grow our business and our platform and our team here in Korea moving forward. So thank you very much for everyone's time. I've left an email address if anyone has any questions. And again, I wish I could have been there today. And I hope that I get invited back to Ulsan soon, because I would love to see all the great new activities that you're doing there. And we're really rooting for the success of all of the fantastic demonstration products and the ways that you're really leading the energy transition here in Korea.
네, 감사합니다. 탄소
Thank you so much. So the energy transformation is really essential, and Ceres has a strong collaboration and bond with Korea, and he emphasized the importance of collaboration with Korea. Once again, I'd like to thank Joseph Reynolds for the presentation. Let's give him a big hand. Next is the fifth presentation. So it's a little bit. So please bear with us. We are almost done. And next one is a Deputy Head PhD Alexei Levchenko from the NTI Competence Center of IPCPLAS in the field of fuel cells and hydrogen energy. Please welcome him with a big round of applause.
Korean partners to opportunity make presentation here in Korea. I'm very pleased to be here in Ulsan and show our presentation. Also, I want to apologize that my presentation will be rather technical. And first of all, I want to start from the brief history of the fuel cells and hydrogen energy in Russia and former USSR. Maybe somebody of you know that hydrogen energy history in Russia starts in 1960s when was started first lunar program and first fuel cells which use liquefied hydrogen and oxygen as fuel and oxidant were used. And also the same, almost the same systems were used in for the program which were created for the Buran orbiter. And this all the systems flight in space, and all these systems were developed for Soviet Union space programs. And after that, these systems, first of all, liquefied hydrogen system were used in aviation. 155 jet was created, which use hydrogen as a fuel, and also fuel cell system which were used for space programs were used in railway system. But in 1990s, hydrogen programs almost suspended, but 20 years ago, these programs was again started, and also we were almost the first organization who make development in this field. And a few years ago was created a competence center which was aimed to develop different materials for electrochemical energy systems and also for hydrogen energy. And also we develop different real examples of vehicles and drones and some techniques which use hydrogen as a source of energy. To make our development, we create a grid consortium in Russia, which includes different organizations. It's industrial organization and research and educational partners. And in this grid cooperation, we make different investigation to create hydrogen energy system in Russia. So what we do with our partners? First of all, we developed different materials which helps us to improve the efficiency, the stability, reduce the cost of the fuel cell systems and hydrogen power system and usage of the hydrogen for different application. And the second type of second direction of our works is the development of different devices with a propulsion system, with an energy system based on fuel cells. We develop and we have production of the membrane electrode assembles for PEM fuel cells, air-cooled fuel cells for low power application, liquid cooled fuel cells for medium and high power application, mobile energy sources for light vehicles and drones, and energy sources for medium and heavy vehicles. In the field of materials, we develop different type of materials to safe storage, for safe storage of hydrogen. These types of materials have their advantages and disadvantages, and main advantage is that it's absolutely safe. We don't have here high pressure, so this system have high volumetric hydrogen content, so it's possible to use such system in home appliances for make power sources for homes. And this system also are well combined with hydrogen fuel cells. Coming back to the fuel cells. In the field of the materials, when we work with our consortium, we developed different materials which helped us to create fuel cells which can work in a very high range of the ambient condition, from very low temperatures and very low humidities. We increase much stability of the fuel cells, first of all electrocatalyst, and reduce the fuel cell stack mass. So all of this helps us to create very stable and very light fuel cell stacks. Here you can see some samples of our fuel cells stacks, low power fuel cell stacks, and fuel cell stack for drone. Using this fuel cell stack, we developed different energy systems for different types of application. First of all, it was energy systems for low power energy system for mobile and power and portable power supplies. They have power from 50 to 500 watts with an energy density from 450 to 900 watt-hour per kilogram. And here you can see one of the example of very small hydrogen power supply system which was used to supply different portable techniques. The next application was small drones, which were used and used now fuel cells as main power source. We create aircraft type drones which have flight time from 6 to 24 hours, and multi-rotor or copter type drones with a flight time from 2 to 3.5 hours. And also we developed different small-sized energy electric energy fuel cells with output power or up to 20 watts for specific energy density, with a high specific energy density. Sorry. And after that, we tried to use our fuel cells in different drone application, and found that drones with fuel cells have several advantages in comparison with battery powered drones and internal combustion engine powered drones. If we compare with battery powered drones, we can see that fuel cell powered drones have longer flight time, volt ampere stability, characteristics have more stability, charging of the hydrogen powered drone is much faster, and in comparison with the internal combustion engine, we have low noise, we don't have vibration, and don't have high temperature output. So everything gives us ability to create perfect drone which combines advantages of both system, battery system and internal combustion system. And now we have several drones which we are ready to supply on the market. Here you can see their characteristics. One rather heavy drone with a takeoff weight of 30 kilograms, with a flight time up to 3 hours, with a payload of 5 kilograms. Little smaller drone with takeoff weight of 15 kilograms, with a payload up to 1.5 kilogram and flight time 2 to 2.5 hours. And also we have plane type drone, which can fly up to 6 hours with a payload up to 2 kilograms. These drones we use for different application. First of all, it's a video and photo imaging of the pipelines of the different long-term objects and different industrial facilities. After that, we widen in our investigation in the field of the fuel cells. We create fuel cell, liquid-cooled fuel cell system, which was applied and in different hydrogen-powered application. For example, we were the first. Just one word about the hydrogen powered drone. Really, we was the first in the world who flight on the copter type drone. It was in 2015, in the beginning of the 2015, we really was the first who flight in this type of drones in the world. And after that, we developed liquid cooling system and used it in the small airplane. It was the first Russian fuel cell powered airplane. And developing different type of light vehicles also powered with the fuel cells. And the next, our direction of the investigation is development and creation of the hydrogen energy storage system based on the hydrogen cycle. We use energy from the renewable energy source, which we put into electrolyzer to produce green hydrogen. We store it metal hydride storage system, and then we can produce electricity in the fuel cells. That was the first our system which we developed. It's just a demonstrator, and now we developing and in production, we have in production this system, which can be used for different application for as redundant power supply and as an autonomous power system with a power up to 10 kilowatts. Also, we work in the field of the hydrogen infrastructure because without infrastructure we can use any hydrogen vehicles. We create here in our center hydrogen filling station, which can fill with the hydrogen different vehicles. We create hydrogen generator. It's based on PEM electrolysis technology, and also now working on the creation of the hydrogen generator, which use natural gas reforming to produce the hydrogen. And this will be a mobile system which can be used for generate hydrogen and fill the different vehicles with the hydrogen. And I must show that we have a great facility in Russia to produce the fuel cells and fuel cell system, fuel cell stacks, to test them. And now we are working with a Korean company, H2WORLD, to create the production line here in Korea, also using our technologies in the field of the fuel cell system and power supplies based on fuel cell system. And now I want to show you a small video presenting our developments in the field of fuel cell. Thank you for your attention.
네, 감사합니다. 러시아는 뭐 기본적으로 뭐
Thank you so much. Russia has a strong foundation in military and fundamental science, so basic science. So he emphasized the importance of AV and also all the advantages of a hydrogen fuel cell. So let's give him a big hand once again. Now we have last item. So this will be streamed.
So he would like to talk about his topic. So we'd like to invite Mr. Alan D. Kenneth, Cummins Global Business Development Director. We invite him through the internet. Please welcome him with a big round of applause.
Thank you very much. I'm sorry I can't be there, of course, but with the current situation, I'll do my best to convey a message and a little bit about how I see the fuel cell and the hydrogen industry ramping up. I've been in fuel cells now for over 10 years and obviously seen the developments as a very niche product now as we're becoming, the hydrogen and fuel cell world is becoming really mainstream, and of course Korea is become a global leader, and here at Cummins we believe we'll be part of that growth initiative that's ongoing in Korea. If you don't know Cummins, we are the world's largest company in heavy-duty engines, close to double any of our competitors, over 100 years of leadership in engine development in diesel engines. And actually, we do have a good presence in Korea with approximately 200 people already operating with our existing customers in Korea. Obviously, with energy transition and global developments, we've obviously seen the announcements at COP26. Cummins has embarked a few years ago on this energy transition. That went through a lot of acquisitions, actually, including the company I was with, Hydrogenics. And as you can see here, we've already built quite a formidable global organization supporting hydrogen and fuel cell technologies. That's based primarily out of Canada, but we also have very extensive developments in Europe, Asia, and the US. Cummins is a US company, and we've developed also a lot of integration and development centers in California as well. So we are a global organization with a global footprint, developing hydrogen and electrified transportation and power applications throughout the world. Long history through these acquisitions. Actually, we have over 70 years of hydrogen experience with electrolysis. We've deployed more electrolysis systems than any company in the world back to 1948. Fuel cells, we started our production in around the late 90s. So we have a long history in that. And as you can see here, some unique developments, projects, applications that we were developing throughout the years, and of course where we are today. I'll talk a little bit more. With that acquisition, as I mentioned, we've developed electrolysis as a core technology and fuel cells. We are embarking also on solid oxide fuel cells very soon, alkaline and PEM electrolysis. And for instance, we've deployed the world's first large-scale PEM system at 20 megawatts. So we are a leader definitely in the electrolysis and the fuel cell space. We've deployed the world's only fuel cell trains with Alstom starting back in 2018, as you can see on a photo here. And I'll talk a bit more about some of the other applications we've been doing. So as a company, I believe we're the only company with a full ecosystem in hydrogen, from production via electrolysis, storage. We actually got a joint venture with a company called NPROX in Europe. They're one of the storage technology leaders. And of course, the different types of fuel cell modules with integrated balance of plant, housing, etc. So we've got a range of stationary and mobility applications in fuel cells. In electrolysis, we've been definitely pushing the gauntlet in terms of scaling up. We introduced the world's first single stack PEM electrolyzer systems back almost 10 years ago now. We're scaling up in the 20 megawatt range as building blocks. And of course, with this explosive growth of green hydrogen globally, we will expand into the 100 megawatts very soon. And you'll see some great announcements coming online regarding scaling up in that manner. In fuel cells, a long history, as I mentioned, planes, trains, automobiles, etc. But our real focus has been heavy duty and stationary power applications. As you can see here some of the applications, some of the sizes of systems. And one of the advantages we have, we believe, is this global service and support network that has been developed by Cummins for almost 100 years. Certified engineers supporting throughout the world, and that ability to support it and expand, we believe, is unsurpassed of any organization. With the fuel cells, we've only focused on heavy-duty applications. We were really never focused on, let's say, cars and other applications in that manner. So our focus has been on heavy-duty trucks, trains, buses, power. We've got some unique technology where we don't require a humidifier. So we found a way to self-humidify. And we also don't use an air compressor, which saves a lot of money, OPEX savings. We use a small air blower. So it's unique architecture, unique design that we believe is the most advanced on the market today. And we've deployed well over 3,000 systems around the world. Where's the market going? Well, obviously, you've seen all these commitments recently, and I put up a slide here. You can see on the right where, as an example, where I am in Europe, most of the automotive manufacturers will stop manufacturing combustion engines. In Europe, you can see the ban 2030, 2025 even, and 2035, where you won't be allowed to deploy fossil fuel vehicles. So you can see that with that growth, we have to transition. Fuel cells are a very logical way. We're seeing growth of and cost reductions in hydrogen, of course. And obviously there's other applications and technologies that are being supported, but you can see here that this is a logical view that we have to transition quickly. We have to have technology to support it, and that technology will be primarily, I believe, hydrogen, especially in the heavy duty space. Opportunities in the pipeline, you can see here we've got many applications, many projects. Now I think the latest count was over 500 billion in green hydrogen projects. And especially in Europe, you can see that the technology is based on green hydrogen. It's not primarily CCUS and other technologies that are still polluting. It is green hydrogen as the focus. Renewable costs are coming down. So we've got a unique transition where when we see the cost of energy coming down and the cost of electrolysis coming down, that target of $2 a kilogram, I think, is attainable. So we can see that the developments and growth in that range will make it, I think, extremely affordable. But also, where do we see other technologies going? And with green hydrogen overtaking that $2 a kilogram, CCUS and other technologies may not be very viable in my view. In terms of the applications on the fuel cell side, at least in mobility, we strongly believe that heavy duty is a real winner. And that could be also a hybrid architecture with batteries complementing each other in terms of range, fast refueling. And of course, with that growth, you're going to see huge cost reductions. The fuel cell market is just starting to ramp up. So we'll see those costs coming down quickly. And here, I've got some good examples, I believe, where battery technology has had, let's say, a 5 to 10 year lead on that. We believe there's a good 50 to 60% reduction coming in the next 3 to 5 years and further beyond that. You can see the targets at per kilowatt moving from 500 down to even close to $100 a kilowatt. In the train market, it's exciting. In Europe, we're already seeing cost parity in 2022-23, we believe, and that's been through various studies that we've seen, and buses with cost parity with diesel in 2024. So these are exciting developments where you can see with cost reductions, we can compete with combustion engine technology quite soon. So to get there, we obviously need leading companies. Cummins, as a major global leader, has been at the forefront of this. As you can see here, some of the world's largest organizations who are looking to hydrogen have approached us and developed MOUs, cooperation, and projects. Some examples here: Iberdrola, the world's second largest renewable energy utility, has a close cooperation with us on green hydrogen. KBR, global leader in ammonia, has already developed an MOU with us. Chevron, another example. A lot of the oil and gas companies are looking to Cummins on their energy transition story and technology. And Air Products has recently announced with us the world's largest truck program, where we'll be converting 2,000 of their combustion engine trucks towards fuel cell trucks. So that's an exciting development for us as well. How can we get there? So there's a bit of information here, you know, how can we get there faster? But I believe if you look at the three pictures on the right, focusing on regulation. So those pictures are all the countries who have already developed a hydrogen strategy, Korea, of course, being one of them, and one of the earlier adopters, for instance. So that's great to see that countries are committing to that. A focus on applications. So you'll see electricity, industry, transport, commercial, residential, agriculture are being a big part of the energy transition in hydrogen. And some of the applications, I use this one here where we actually had the world's first 24/7 PEM fuel cell running in Korea at a megawatt level. So we believe that those applications, direction, and growth in applications will be important for us to scale up, increase production. For us, a key component of developing our story in Korea will be creating more partnerships, and we're embarking in that avenue as well and open to other ideas with Korean companies. How can Cummins be a part of that story? Well, we believe with 70 years of history in hydrogen, we've got some great examples. We developed the world's first large fuel cell bus fleet in China back in 2018. We've got the world's only trains running, and we've got orders now for over 200 trains in 5 countries in Europe. We had the first megawatt fuel cell running 24/7 in PEM. And then, of course, on the electrolysis, large-scale electrolysis and orders in the hundreds of megawatts. Also, an experience in over 65 fueling stations. So we believe we've got the global reach. We've got JVs and partnerships. Cummins does know mass production. We've got, I believe, over 60 factories worldwide. So that ability to understand and ramp up is definitely within the Cummins organization. We're the only company with hydrogen production, storage, different types of fuel cells under one organization. That gives us the ability to be a partner in Korea. And on the lobbying front, our CEO is actually a co-chair of the Hydrogen Council. Hydrogenics ex-CEO is actually the executive director of the Hydrogen Council. So obviously we have a very good history in developing and understanding and being part of the hydrogen ecosystem. So with that, just to summarize, we've got a century of powertrain innovation, capabilities, and a global footprint to support the energy transition in hydrogen. Thank you very much.